I hope you enjoyed your break. So we will be starting our first talk with Mr. Mr. Thanasis Politis, who will be talking to us about AI cloud management and the integration of AWS Python SDK with Anthropic's MCP, or else Model Context Protocol. So let's give him a warm round of applause.
Thank you for the introduction. Hope you can hear me well. Good morning, everyone. It's a Friday morning, so extra thank you for being here on a work day. Amazing that we have the first PyCon conference, so that alone also needs a round of applause. And thanks to the organizers for the invitation. So let's dive right into it. I am Politis Thanasis. I'm a solution architect and a software engineer, and I work for a company called PCG International, where we are, is it better now? Yeah. Where we are premier partners of AWS. We're doing AWS migrations, but we're also developing cloud native applications into AWS. So as you can understand, our interaction with AWS is not constant and daily. At some point, 6 months ago, starting fiddling around with MCP, Anthropic announced this new protocol that essentially tries to establish a standardized way of communicating with LLMs, but in a way that will be able to give them extra functionalities, not unlike like an agent that can orchestrate things. This is more in a way to translate user prompts into actionable effects by creating this layer that can be translated to a standard REST API or any other service. So some brief information, what is MCP? It is an open protocol that anyone can use from Anthropic and is able to integrate LLMs into their workflow. It currently supports 2 transports, local communication as a local service through standard input-output, and through server-side events. Someone can create a remote MCP server to communicate through the internet with his MCP client. Again, Anthropic tries to promote this as a standard way, and again, 6 months later, it seems that the industry has adopted it. We see again and again that everyone is using this protocol to create libraries. They offer their own MCP endpoint. We even have new SaaS products that, along with their REST API, they also give you their MCP endpoint to communicate with. A brief comparison between the two. REST API is what we know, true and tested. The idea behind it is that you have a design document, your API specification. Someone can read the specification and implement it, talk with a specific endpoint, and of course, as it says, single purpose in the sense that you request for a resource, you get something specific back, and it's all governed through this shared specification between the client and the server, almost like a contract that if you honor the specification that I'm giving you, then your client would work with my service and everything should be fine. MCP is a bit different. It's specifically created for AI design systems, or Gen AI, most probably design systems. Being an RCP protocol, an RPC protocol, it does dynamic discovery. There is no specification. There is no open API or Swagger in MCP. You query your MCP server and you get back the available tools to you, just like you would do on an RPC server. Self-describing in the sense that it's not the user that needs to understand how the MCP works. It's the client that has an LLM attached to it that will understand, based on this discovery, how the MCP server works. And of course, it's context aware, meaning that in a session with an MCP client, or as we're going to show later on with Anthropic's Claude, you have this context that at any given point you share with the MCP server, and based on that context, understands which tools to use and what information to get back to you, again, without having to know what are the endpoints, what is the API, or what is the documentation. Let's try and match some primitives. Instead of post request, we have tools. It's the idea that you define something as an actionable as an action. The LLM, the model, will call that action for you. In some cases, you don't even know what's the name of the actual tool is. And it is, again, the idea that you send data and you get back information. We have resources. This is the idea of, this is static content that we can share with the MCP client. Documents, calendars, a list of, as we're going to see later on in our case, list of AWS accounts you have configured locally so it can use them to fetch information. And finally, we have prompts. This is the idea that you can write some pre-existing, predefined prompts so your MCP server can share those with the MCP client during discovery, and it can use them as suggestions when you use your MCP client. So everything is happy. It seems that everyone is happy about it on the internet, but no, this is the internet, so it's not. So let's see how much that statement is actually true. It's in a bit, and let's see some architecture. So let's take the example we showed previously and see a quick diagram. We have the client. We will do a standard GET request. We will talk with the API server. The server will execute some backend code to a database, to another service or whatever. You get the response back. And of course, you get your JSON formatted response back. In our case, the client needs to know the protocol, needs to know the specification in order to properly request for the data and present the data. Let's do the same example with MCP. Instead of a structured request in terms of a JSON format, we have a sentence, we have a prompt. What's the weather in Seattle? The MCP client, which has access to an LLM, either a local one or a remote one, will get this text, index the tools that the MCP server gives it, and then based on the LLM's matching, it will say, okay, the best tool here is the get weather tool that the MCP server is offering to me. It will structure the JSON internally. This is something that the MCP protocol does for you. It will send the request as an RPC request back to the MCP server, and then it's the same thing. The MCP server, as any other backend service, will talk to the database or another service. You will get back the response in JSON, but the difference being that the JSON is intercepted again by the MCP client. And the user will essentially get back context. And this is where we're talking about context aware. You have a conversation, but instead of having conversation just with a model, you have now infused information into the model, not like a RAG or like fine-tuning, but with dynamic data that can be constantly changing from a specific source. So, as I mentioned initially, as a company, as employees, we work constantly with AWS. So the idea came up when it was announced that, okay, let's try to integrate it with the AWS API, and specifically the Python SDK, which, as a company, I think we use almost 90% day-to-day operations. As a client, Anthropic offers their own client, the Cloud Desktop, which natively supports MCP. Of course, we're going to wrap this around the Python SDK. For anyone that's familiar with AWS, that's the Boto3 package that you can find used again and again when talking with AWS API. And we need a server. So at that point, and still is, FastMCP is right now, I think, if not one of if not the prominent, I think it's the most, if not the most prominent, it's definitely one of the top 3 MCP server solutions. And if I'm not mistaken, version 1.5 has been integrated into the Python standard package, but don't quote me on that. I think I saw it recently. So again, what's the idea? We have a client. That client can be either through standard IOPS, Cloud Desktop. It can also be any other client that implements the MCP client protocol through server-side events. We boot up the MCP server module. Underneath that, we describe and give him access to the Python package in order to make those calls for us. We have created, of course, some useful core utils functions, but that doesn't affect the design. You could have quite easily done that without it. And then internally, the Boto3 SDK will communicate to the AWS endpoint. So I think, okay, yeah, sorry. So let's see how that's done. Spoilers. This is a standard function to use. You have your Boto3 instantiate object, you get your available profiles. So how do I expose it as an MCP resource? Very easily, you use this annotation. So using the fast MCP package, all you have to do, you can go on your existing code, and this is very important. If you already have a Python library, if you already have an API running, you can go into your existing code right now, adding this decorator and essentially expose it as a resource on an MCP server. Same thing with any other standard function like this one that gets us the list of S3 buckets. We define it as a tool, we give it a name. Keep in mind that the name in the description, in the annotations, can be different than the actual function name. In some cases, you might want to give more context instead of using something like a variable. And the description can be almost like the documentation for your function, but it can also vary. It can give examples, for instance, on how to use it. The MCP package with the decorator reads both the functions code, the inputs and parameters, the output parameters, the description and the name, and creates this as a context for the LLM to understand how to use the tool. So, okay, so Thanasis, what are you talking about here? Do we have to go for each AWS function within the Boto package, write it by hand, and then annotate it? That would be a fool's errand. And this is where it becomes interesting when we are dealing with LLM. The Python package very conveniently has an SDK wrapper. You can send your request back to the AWS API without having to specifically call that specific function. You can give the name of the service and the operation you want to do. For instance, S3 list buckets. It can also be used through the wrapper and say service name S3, operation name list buckets, and through this wrapper, the Boto3 package will construct that request in the API layer and send it as you would have if you have called the native function. And this is where LLMs come in hand. So all I need to do essentially to the model is explain that there is a tool that if you know the documentation of the API, you know the parameters, you can use the wrapper yourself, them being the model, to construct the call and send it. In my code base I'm going to share later, you will see that I have created some of the functions like S3, etc. But quite honestly, and I haven't tested that yet, I could just strip everything, leave only the SDK wrapper function, add as a knowledge base or some other way of resource the whole API, which would create an issue with the context, but that's another discussion. Hopefully, right now, because of Anthropic's and AWS very close interaction and partnership, most models available in Claude already pretty much know the whole AWS API. And once I explain that to the model, they can construct those calls for me without actually having to write each function one by one. And we're going to show it later on in the demo. Let's put all these things together now. So we have the user. It says, bring me all my S3 buckets from a specific account. It will be translated as a JSON RPC request, send it over to the MCP server. The MCP server will talk with AWS API, and this all will go back to me by showing me a structured way of my buckets. It can be a list. It can be anything I want to, as long as I instruct it in the prompt. So we cannot, of course, leave out security. It is an issue. I think already articles are spanning here and there about the issue with MCP. Anthropic very deliberately have not included a security or authentication module into MCP because they want each implementer to just use their own. There are some talks to standardize something basic at least, but for now it's mostly up to you to either put in front an authentication service, a token, some kind of OIDC or anything. Because right now, for instance, one of the issues that if you have an MCP server online and people authenticate then for their services, now you have a server sitting there with all these tokens ready for the taking. Like someone can just grab that server and you get all these tokens right away stolen. Confused deputy is a problem. In some cases, the MCP client, because it is an LLM after all, might take some leeway and try to do things beyond its scope if someone can inject something clever within the MCP server context. Prompt poisoning, similar to what I mentioned. And of course, the standard session hijacking, because again, we're talking about a JSON RPC, as our guy previously told us in the tweet. So the same issues that you would face on a standard JSON RPC server, they still apply here. What anyone can do, standard stuff, making sure that we don't use long-lived tokens. You can authenticate for the service, but make sure it's not a long-lived token. You have to use some kind of session mechanism that will tie the client to the server, and again, make sure that you either you refresh it or you just revoke it. Input sanitization, of course, which most commercial clients do, like Claude, etc. But if you're writing your own, you have to be extra careful about it. And something that can be done maybe on a industry or production in industry level, you could have mutual TLS, like you can have designated clients that only those clients can connect to the MCP server using mutual TLS mechanisms. Okay, so that's enough for the talk. Let's show some action here. What time is it? Okay, have to be fast. So what we have here is, I'm going to show how you install it, first of all. So with the standard, with the local server, all you have to do is open your configuration. I think that's better, right? So all you have to do is open your Claude config on your desktop, define the list of MCP servers you want to use, you give the execution command, and then that command will open the server, because as we said, this is not an HTTP-based communication. It just talks through STDIO. And that means that if everything goes well, if I open my, yes, and I go here, I can see my server being registered. This is the resources that I define. So what I told him here is that get me all the AWS accounts I have configured in my laptop. And then here in the tools, if I go in the server, I can see the discovery that's being done. These are all the tools that my MCP server is advertising to the client, and it can use, of course, the Claude client gives you full control. You can disable some of them, etc. And we can see we have some common ones: cost information, EC2 information, the SDK wrapper, of course. So for the demo, let's do some prompting. List all my AWS accounts. So it will use the context that it got from the API. Well, perfect. These are two demo accounts I have created. Let's use this one and say, okay, use as AWS profile in Frankfurt and fetch me all the EC2 instances. So again, I just say Frankfurt, I don't say EU Central 1, but that's the official code of the Frankfurt region in AWS. But the context itself, because the LLM itself will understand, it says Frankfurt. It means EU Central 1. So we see here that using the predefined tool, it took my context, it formatted in a request, I didn't have to do anything, and it gives me back the formatted response. This is all hidden from me, but Claude allows us to review if we want to, and it will give me a very brief information about this. Let's do something else. Let's say, how can we make this account more secure? This is a more broad request, like it's not a specific tool. I don't have a tool that says. So in this case, it can answer me on the existing information, but then it realizes that it doesn't have the full context. So then on its own, it will go and also fetch the security groups, and it will give me some very, very important information. This account is deliberately, as again, is a demo account. This is not a client account. And I can say, any more info about the rest of the services? So right now, it should use the wrapper because it will try to get the databases, but at some point later on, it will realize that the current tools doesn't do it. Yes, always allow. Ah, here it is. So it's like, I don't have an action to list your IAM users. So on its own, it realized I have the wrapper. I can just use the wrapper because I know how to call the wrapper and use it to fetch information. And it will do that without me having to specifically tell him, use the wrapper. It understands from the context that if the tool is not available to you, you can use that generic function. It will. So it's fetching flow logs. Yeah, because I told him whatever, so it's going to try to collect as much as they can. So, here it is. Okay, so it fetches the information. It will create a report for you. Why is that useful? I mean, why do I need this? I'm a solution architect. I can open the AWS account and I could very easily do that. This tool is initially inspired to give it not to solution architects, but to people within the company that don't necessarily have that much of an understanding. It can be a junior developer. It can be a finance guy that can ask, what's the latest cost that this user is doing and how could we optimize it? It's not only towards technical people, but anyone that with not the necessary knowledge to understand the AWS console, which is quite chaotic, could very easily get some context around it and get some information. And again, the sky's the limit. I submitted this talk around March 23rd. AWS created their MCP repo on March 20th. And within 6 months, they have gone from one MCP server to all of these MCP servers. So as you can understand, they're quite heavily invested in this. And there is a general idea that an MCP server, just like an agent, should be focused. I don't necessarily agree. I think MCP, it's like a REST API, it's a wrapper. You could create a full monolith if you wanted to and just expose an MCP with all the tools available. I know that people tend to go to the whole microservice thing and compartmentalization thing. And again, for the MCP server, the current dogma is that it needs to be very specific. If you visit AWS's MCP server list, you will see they have very specialized MCP servers. You can do it like that, that's fine. But I honestly believe that being just another integration, you can offer it as a service. It doesn't have to be such compartmentalized. Some useful links if you want to share. So go FastMCP, it's the FastMCP server. I think they're now in version 2 that has even more goodies inside. I think it can actually auto-detect your code and do the annotations almost automatically. They've done an excellent work, a pure Python project. You can check the code of this presentation if you want some further information. And of course, Claude, you know, AWS, you know, you can always create a free account to test it with a free tier, no need to spend any money, right? And the side of our company, as I said, we're doing AWS migrations and cloud native development. Thank you.
Thank you very much, Mr. Thanasis. So, any questions for Thanasis on the talk? No? Yes. Yes.
How do you test these environments? Test if they return the right value, the right response, if it is complete? How do you troubleshoot and write tests, let's say, for this new era?
You mean test the responses of the MCP server or test the environment itself?
First, troubleshoot if the answer is correct,
yes.
And and then write a unit test, let's say, to make the code more robust. And
so this is actually done for us by the library itself. The way that the API, the ABS API works, if for whatever reason the call fails or the parameters are not correct or anything, you'll get an error back. So immediately the LLM will say, I wasn't able to do that, let me try something else. So if, for instance, it will try to call through the wrapper, a function, and it fails, it will retry at least 5 times. And on the 5th time, we'll just say, I don't know how to do this call or anything like that. So in terms of testing, the library itself is tested for us. I mean, we don't actually add something to the Python library. We're just adding this wrapper on top. The other benefit here is that we are running that on accounts that we're aware. Like it's almost like we know the trick already. If I see something that's weird, if I see something like this account has spent, I don't know, 1 million credits, I'll be like, no, that doesn't make any sense. But in most cases, since the API is deterministic, we rely on that because it will either give information or it will not. The LLM itself can, of course, it's not deterministic, but there's never been a case where the JSON response was malformed or erroneous, and the LLM presented that as a valid response. And I think this is handled internally by MCP. I don't think we have to do anything on that.
Okay. Any more questions? Yep.
Hey. Thanks for the talk. And for me, it's maybe simple. So for you, maybe simple question. For me, it's pretty hard to understand. The first one part is how to implement the roles for the interacting between cloud and MCP server. And the second part is how to implement something kind of IAM roles for the actual user and the LLM, which is user, I mean, with the print prompt.
Yeah.
And fetch the information about the cloud, about yeah.
I'm going to switch to that slide because it relates to that. So the examples that I show use standard IAM access keys. These were not through Identity Center. This was not through an IDP. So that means I have created an API user almost within the IAM of AWS with limited permissions, read-only permissions. I cannot create an EC2. I mean, I could if I wanted to, but we don't do it through the LLM. So right now, the only valid case would be manually creating credentials, storing those credentials either internally or through a vault that you could integrate with the MCP server. I think there is a project right now to also handle single sign-on with MCP, but you cannot avoid the browser interaction. Like you have to go to the browser, authenticate, create an STS, a short-lived token, and use that then. Because since this is running locally, this is a local server that I demonstrated, it can fetch the information from your .aws folder and see that you have authenticated and use the refresh token there. On a remote MCP server, good luck. I don't know any user, any client, and we would say to our clients, don't do it. That would, if a remote MCP server asks them for their AWS credentials to authenticate, it's like a big no. Like that would be a total it's not gonna work, and quite honestly, it's frightening that someone could do it. But no, right now I think if MCP, and they are very heavily invested on this, Anthropic, all these companies, once they solve a bit the security issue, and I think this will have to come through an identity provider, you need a third-party service to hold these tokens that you can quickly, easily revoke. Then on a remote server, you could do single sign-on, you would be able to give access. But otherwise, stick to the local always create IAM access keys, limited permissions, and always with revocation policies, and always, renew those credentials. Exactly, yeah. Yeah. Well, in our case, I'm using the client directly through Anthropic. That means that I have an account with Anthropic that I'm using here. So I didn't have to authorize anything through this client. Quite easily, there could be a client, you could create an MCP client that could also handle authorization, but again, I don't think people will trust it to do that. If you trust them, if you trust anyone,
Okay.
Sure. Security is all about trust.
Thank you very much. Thank you very much, Thanasis. So you can continue the discussion outside with Thanasis and give a warm round of applause. So we will be having a 5-minute break for the next speaker to prepare. Okay, I think we are ready to start, to continue with the next talk. So our next speaker, Jan, will talk us about consistent importing. Let's give him a warm round of applause. No.
Hello. Okay. Hello, everybody. The topic of the presentation is consistent importing. And on the right side of the screen, you have a QR code that you can use to download the slides and have it during the presentation, if you wish for. And my name is Jan Bielecki. I work as a senior full-stack developer. And a few facts about me in programming context. The first program I wrote, I was about 10 years old, inspired by my brother, who was into programming those days. And the first Python code I wrote, it was 10 years ago. And since 2019, I work with Python on daily basis. I use it at my work. And I work at Ørsted, and Ørsted is a global leader in offshore wind. And we have around 8,000 employees. Within those, we have around 1,000 IT specialists. And within those, we have around 100 Pythonistas, so people that would call or say that the main technology they use is Python. And the first section is about why I'm even talking about this topic. So in our current project, we have this strange re-exporting strategy. And my colleague asked me, who joined our project, why do we do so? And I actually couldn't answer. Another colleague introduced it, and he was not working with us anymore. So I did some research to figure out what are the advantages and disadvantages of this approach. And this strategy look like this. We have an example of that. So let's say that we define a clause node in the model geometry node module. And then what we do, we re-export it in the init.py of the package of the node module. Then we re-export it in the root package, so model, in the init.py. And then from some other root package, we just import it directly from the model module. So there are some advantages of this approach. So there's kind of encapsulation of the whole root package. We have all the definitions as a single entry point, and imports are pretty shorter because you don't need to use full path to the module. You just used name of the root path. But there are obviously disadvantages, so you need to maintain that. You need to do it every time. Then IDE is confused because when you type node in any other module, it will suggest to import it directly from the module where it was defined. And it's hard to automate. I mean, you can write some script that will check if you do it like this, if you follow the strategy, but it will just introduce some complexity. And this approach has another advantage that I will talk about later. And what about consistency? So here is a photo of Mark Zuckerberg, and he just reduced one decision that he needs to make during the day by one because he uses the same shirt every day. I mean, the same type of shirt. So we are not AI models, we are people. We have some amount of mental capability that we can use during the day. And if you can reduce some decisions, then those decisions that left, they will have better quality. And that's how Python wardrobe looks like when it comes to importing. So we can do it in many other ways. And if we don't follow any strategy, then you actually make those decisions every time you write code, every time you import. And this will be a pretty boring section. You probably know most of this stuff here, but I hope the following section will be a bit better. So how importing in Python works. Let's start Python interpreter and define some function, and we can obviously execute it. It successfully executed. Then when we exit the interpreter, we don't have access to the same memory anymore. So when we execute another Python interpreter, it's obviously not there. So that's why we have Python module. We can reuse our Python code. And if we can reuse it by importing. And if we import a Python module, we just execute all global statements from there. And if we get into a definition of a function, of a class, or a variable, then we save it as an object and put it as an attribute of the module that we import. So in this case, if we import my module, then just line number 5 will be executed. We have it printed, and we can see what are the properties and methods of the my module object, because this my module is just a Python object, like everything in Python. And you can see that we have a hello world there. And hello world is our callable, we can call it, and we can see hello. And then we have a Python package. So Python package is just a set of Python modules, put it into the directory, and together with those modules, we can have sub-packages. Another concept, good to know it, is system path. So system is a standard library, and it has an attribute path, and path is just a list. And if we print it, we can see different directories there. And those are the directories that we look into when we import anything in Python. So if you would like to import some module in Python, you need to make sure that this module is inside one of those directories under syspath. And you can manipulate the syspath list. And the easiest way to manipulate it is a different way of executing your code. So you can execute it as a module when you put a -m flag and then path to your module with a import syntax, so using this dots instead of slashes. And then on the first place on your system path, you will have a current working directory. But if you execute it as a script, so just provide Python and path to this module, on the first place on the system path, you will have parent of the module that you execute. And there are other ways, like this is the most clean way to modify system path, but you can use other ways like setting Python path environmental variable. You just provide a set of paths there divided by colon, and let's just provide /example, and anything can be here. And let's see what is under system path. You can see that they both landed at the first places, and if you don't put /, then it's just treated as a relative directory, so it's prefixed with the current working directory. So anything can be here is prefixed with the current working directory. And actually you can put everything under system path. You can put Boolean or any other object. It will still work. I mean, it's just a list, so you can append it, but importing, you will not break importing because of that. Then you have a concept of namespace package. So namespace package has been introduced in Python 3.4. And let's say that we have a situation that we have two packages with the same name. The name is my package, and they are placed in some path and some another path. And if in our system path we have both of those paths, then only the package from the first one will be imported. So if we try to import my package model, it will succeed. But if you try to import my package computation, it will fail. And namespace package can be helpful here, because to create a namespace package, you just need to remove the init.py file from both of those packages, and then they will just overlap. So the my package from some another path, we just overwrite everything from the my package from some path, and it will work. Now there will be a section about some recommendation, and part of those recommendations are from PEP 8, so a style guide, and part of those are just from my personal experience. And the first recommendation is to place your imports at the top of the file. Why? Because you are transparent about dependencies that you create for this specific module. Another recommendation is actually an exception to the first one. In this section, there will be a lot of exceptions. So there are some recommendations, but there are also a lot of exceptions from them. You don't need to put import at the top of the file, especially if it's heavy to load. So for example, PyTorch, it takes almost 2 seconds. If you would like to save this time, at some conditions, then you can actually do lazy loading. What is lazy loading? You just import module right before you use it. So in this case, we import torch inside function evaluate model. Another recommendation is to not overuse type checking, especially to solve circular imports. So type checking is a flag that you can use, and this flag is only true if your type checker checks for the types in your code. But if you just run your Python code, it is set to false. So in this case, your IDE will be not confused with what is torch module. The suggestions about attributes of the module will still work, but on the runtime you will not import torch at all inside this module. Yeah, so you can sometimes use type checking, but don't overuse it, especially for circular imports, and on circular imports I will talk more soon. Another recommendation is also from PEP 8, is that imports should be grouped. So if you have those 3 groups, on default you have 3 groups, you have an immediate visual separation of your dependencies inside your module. So the first group is just a standard library imports, the second one is third-party imports, and the third one is your local packages. Another recommendation is to import 1 definition per line. And what for? Let's say that we have a module common constant and we would like to import 2 different definitions from there. We put it in a separate line just to reduce version control configs. It's a small thing, but if we can reduce merge configs, we don't like merge configs, so let's do it. Another recommendation also from PEP 8 is to use absolute imports. So on the default, absolute imports should be used because they are more informative, less ambiguous. But there are some cases like encapsulation, or you have a complex package layout, so you don't want to have imports that have 100 lines, 100 characters. Then you could use relative imports, but actually there's a note in PEP that standard library code should avoid complex package layouts and always use absolute imports. Another recommendation is to use only well-known abbreviation. So we know NumPy as NP, Pandas as PD. But if you introduce your own, make sure that everybody understands what does it mean. Another recommendation is to avoid using namespace packages. So the namespace package is this thing without init that can overlap sub-packages with another package that is named the same. The current recommendation is not to use it. So always on default put init.py in your Python package. There could be exception if you know really what you're doing and it makes sense, it will not introduce some uncertainty, then it's okay. Another recommendation from PEP is to avoid using wildcard imports. And wildcard import is this asterisk import. So with this asterisk import, what we do, we obviously execute the whole module as in every import statement. And then we save all the objects that we get from this module as the attributes of the module that we are importing to. So it will pollute namespace of our current module, pollute with who knows what. So it's better to avoid this ambiguity. But obviously there are some exceptions, and this exception was also mentioned in PEP. So we can have a situation that you have basic implementation of some math stuff, and then you have some accelerated implementation of this. But this accelerated implementation is only installed in some specific circumstances, for example, on a specific operating system, or only if you have a GPU. So you are not sure if you actually install it. You can have some proxy, let's call this proxy public API, and this proxy uses asterisk import to override all implementation from base implementation with implementation from accelerated implementation. And then in your script that you execute, you can use this proxy safely. And this is the last recommendation, and it's to import directly, import the definition directly from where it was defined. So this thing that I mentioned about the strange strategy that we have in our project, I would not recommend it. We here import node from model and not from the module that the definition is placed originally, so model geometry node. But there obviously could be some exception, and the exception is encapsulation. So you can have some kind of proxy, for example, proxy on operating system, and you actually import copy file on Windows, from Windows package or from Linux, depending on what system you are using. And then you can import this copy file from this proxy module and not directly from where it was defined. And now will be the section about how imports impact design of our code or architecture of our package. Why we should even care about this clean modular structure? First of all, it's more beautiful when you look at such a structure. You can at first glint get an idea of what is going on in this package, and you can easily remove stuff, move stuff around. You can easier find stuff or implement new stuff. And you can also run specific tools for a specific part of your code, for example, PyTest on some geometry subpackage or linting or icon subpackage. And here we see pretty clean design, modular design of our Python code. And yeah, it looks pretty. And the one advantage of this design, it's hard to see. You need to have more time to actually find out about this, but it does not have cyclic dependencies between packages. So it has a hierarchical structure, and it's easier to maintain code when we don't have cycles at all between our components, and in this case, between Python packages. And to do so do not have those cycles, we could follow a cyclic dependency principle. And here on the graph, we can see some of the components, interactors, authorizer, and entities that are coupled together. So there's a cycle, dependency cycle between them. And if you avoid such cycles, it will be easier to maintain your code. With such cycles, it's harder to test your code because those three components actually act like one single component. There's no boundary between those. And probably you know this import error due to a circular import. And the question is if this is a bug or a feature of a Python. Because in Python, when we import a module, we just execute all of the statements there. So if we have a cycle between imports, then we will go to infinite loop of importing, because it will try to execute this one, then this one, then this one. So it's not possible. That's why Python check that and throw this error. But in general, it suggests that you have some design issue with your Python package. And it only works on the module level. So if you have circular dependencies between Python modules, then you will have this error raised. But with this re-exporting strategy that I mentioned at the start of the presentation, you will also not allow your software to have any cyclic dependencies between packages. Because let's say that we have this GUI and model as root packages, and now GUI depends on everything from his sub-packages, and the model depends on everything from his sub-packages. And if we import anything from model to GUI, it doesn't make sense that GUI depends on the model. But then when we try to import something from model to GUI, it does not make too much sense. I mean, why model should care about existence of GUI at all. But in this case, it will not raise import error because we don't have a cycles here. The imports are directed, and we don't yet have a cycle, but if we follow the strategy fully, so if we import directly from the root package, then we create a cycle. So another advantage of this strange method of re-exporting that we have in our project is that you cannot have circular dependencies between packages. Yeah, this is just a proof that it will not work. It will just raise the circular import error. And now the section will be about tools that you can use to enforce those recommendations that I talk about. And the first tool is RAF. If you don't know RAF, it's pretty cool because it's pretty fast and it's a linter and formatter. And to enforce the rules I was talking about, you just need this simple configuration file. So first we turn on isort to sort alphabetically our imports and group them. Then we have a rule about importing only at the top of the module. Then we have a rule about using absolute imports. Then we have a rule about not using wildcard imports. Then we have a rule about, it's actually isort config rule about forcing ourselves to use single line for importing each definition. And we also have this known first party. I actually use it because in our project we have several packages in the root of our directory. So I need to explicitly mention all of them to not confuse RAF and IDE. What are my known first party packages? Sorry. And going back to this re-exporting strategy, I removed this from our code. I didn't like it, but I would really like to save this acyclic dependency principle. And I was looking for a tool that can help me with that. And I find import linter tool. It's an open source tool. And in import linter, you can just define different kinds of contracts. And the simple contract, it's contract of type forbidden. So we can just explicitly mention that GUI cannot be imported from module or DB modules. But I was looking for something more generic. I don't want to explicitly list all of my packages. I just don't want to have cyclic dependencies between packages at all in my project. There was no such a contract, so we together with the help of maintenance from import linter, we developed it. It's not yet released, but you can check it on my forked repo. And the configuration just looked like this. It's pretty simple. The one flag is pretty useful. So consider package dependencies. You can turn it to false, and then you check only for modular cyclic dependencies. You can check it to true to check the circular dependencies on package level. And I ran it on Django, and Django root package has more than 150,000 lines of Python code. And this is the outcomes. So in Django we have 167 cyclic dependencies, and within those we have around 88 cyclic dependencies on a package level. And now the question is, if Django will start now and they will use this acyclic dependency principle, will it be more fun? Will it be more easy to maintain this repository following the acyclic dependency rule when creating your Python structure? I think the answer is yes, but I don't have any data yet to confirm that. So I encourage you to check this out for yourself. Check if you have any cyclic dependencies. Probably you have some. Just to sum up, importing in Python can be done in many different ways, so it's nice to choose one because then you will reduce decision fatigue. And clean modular structure of your Python code matters. It has a lot of advantages, so it's nice to put some effort into that, not too much, but some. And I think that following a cyclic dependency principle, it could lead to better software design, to better design of your package. And using tools like raf and import linter, you can automate checks of those recommendations that I mentioned. That's all. Thank you very much for your time.
Thank you very much, Jan. We do have 2 minutes for any questions for Jan. Anyone? Yes.
We are very heavy users of import linter. So when do you expect to actually release this acyclic support?
Thank you for this question. We are in the middle of development and we still didn't figure out the final form of this contract, but it already works, so I hope it will be released soon. Maybe I will try to finish it next month together with maintainers.
Okay. Anyone else? Any other question? No? Okay, you can still find Jan outside on lunch for any other questions. Thank you very much, Jan, once again.
Thank you.
And we continue with a 5-minute break again. next talk from Illinois Harbottle, and she will be talking to us about Python in the healthcare domain. And her talk is Lung Biopsy, Python's cut above the rest. So let's welcome him on stage. Her.
Thank you very much. Welcome, everyone. As mentioned, my name is Illinois Harbottle. I'm going to talk to you about medtech, specifically medical robotics for lung cancer. So, let's get started. Okay. Let's start with a thought exercise. So without raising your hand, I would like everyone to just stop and think. How many of you know someone who has been impacted by cancer of any form? Maybe neighbor, coworker, friend, cousin. How many of you know someone who was impacted by lung cancer? Okay. So for most people, that's where the conversation ends. But for us, engineers, scientists, developers, problem solvers, the human impact is just the beginning of a systems level challenge. So, just in Greece alone, lung cancer is the leading cause of mortality for men. It is the third leading cause of mortality for women. According to data from the World Health Organization, over 22% of all the cancer deaths in Greece are due to lung cancer. So this makes it a primary health concern, and it's one that hopefully we could address with every tool at our disposal. I also wanted to show you another study. This one was from a hospital in northern Greece. It tracked patients for over 18 years. And out of a really large sample size of over 15,000 patients, a little over 5,600 were confirmed lung cancer cases. And the ratio of men to women who were confirmed was higher for men than women. The ratio was 2-to-1. So it means that men were more likely to be diagnosed with lung cancer than women in this particular study. So what this means, and comparing it to the rest of the world, globally, every year, about 2.4 million new lung cancer cases are diagnosed. That's just an estimate. I've seen higher. But what this also means is that the global surgical market size by the year 2032 could be about 16 billion euro. So this means that not only are people trying to solve the problem, it is an area of great opportunity for problem solvers. So where does that bring us to today? We're talking about Python, about engineering, and science. So the question is, how do we empower clinicians? Because it's not just about statistics, it's about lives, and it raises several critical questions. We know usually with cancer, the earlier you find it, the better. There are better chances of survival. And nowadays, with medical robotics, we can make these types of diagnoses and procedures less invasive and more accessible to a lot of different people. So again, how do we empower clinicians? So I have a poll, and I'm going to drop this link into the channel in our shared Discord for this room, in case you can't read that QR code. But if you could pull it up. It'll say it didn't start yet when you get there, but I'm just giving everyone a few seconds. Okay. So hopefully everyone has had a chance to go to the site. And now we're live. Okay, I like how some people already started. Once I figure out why I can't get this to maximize. Okay. So this is a thought question because I would like to know who's in the room and answer to the best of your ability. What do you think is the most transformative impact of medical robotics? And for some reason, I can't make this thing go away. There we go. Okay, so I think 34 is a good number. Thank you, everybody who decided to participate. There are a lot of ways to answer this question. What is the most transformative impact of medical robotics? Someone who is already familiar with the concept might already have a strong idea of what this could be. And the truth is, depending on your profession, depending on your experience in healthcare, all of these could be correct answers. We'll dig deeper into all of these as we go throughout the talk. Okay, let's move on. Once I figure out why I can't get it to move. Okay. So hopefully it works on your screen that you can answer this next question. What is the biggest hurdle in getting a robotic system to see inside of a human lung? Yes, it's working. So give everyone a couple more seconds. Okay. Thank you for everyone who decided to participate. Real-time fusion is an absolute concern. Happens all the time in the field. Lighting and contrast issues, depending on your camera. Lack of a clear pathway through the lungs, that's absolutely a challenge. And image distortion. These are all really good insights. Thank you, everyone. Okay, let's move on to the last question. And I hope this works. No, wrong one. Of course it went out of order. Okay. You kind of already saw this. What is the most difficult engineering challenge in medical robotics overall? Okay. Okay, great. So we'll wrap up the poll. Thank you for everyone who participated. These are all different areas of concern depending on your experience within software or robotics and controls. Or if you're a product owner, you'd be concerned with regulatory hurdles, UI, UX, human interaction. That's a completely different field. So these are all areas, depending on your background, that might be of the highest concern to you. But these are all areas where different experts within their field need to integrate and meet at the table in order to come with a realistic solution. So that was my attempt to understand who's sitting with me in the room today. So thank you for participating. Let's see if I can make this work again. And it's not. Okay. All right, so let's go back to the talk. We talked a little bit about what was the motivation for medical robotics in a PyCon conference. So right now we'll get into a deep dive, and at the end we'll get into next steps. Okay, so the core problem that we're trying to solve is locating a tiny abnormal spot that may or may not be cancerous in the lung. And we have had ways of doing this through X-rays, MRIs, CT scans for years. We know this works. But imagine if you go to the doctor because you detect something strange going on in your lungs. Your doctor says, okay, let's take some scans. The scans come back. Traditionally, in the old days, you would go into an operating room for a biopsy. In a biopsy, the traditional way is the doctor would cut you open, take a sample, patch you back up, and you'll stay in the hospital recovering for weeks. And that's a lot of downtime in the hospital, just recovering. So when we talk about what about today, modern times, well, for the last over 25 years, minimally invasive robotic-assisted surgeries have become more and more widespread and popular throughout the world. For example, there's a company that has held over more than 15 million lung cancer biopsies across 69 countries in the last 25 years. And the idea behind a minimally invasive surgery is that instead of making a huge cut into your body, the doctor can either make a really small cut or no cut at all. So you can imagine that if the doctor can do a biopsy without cutting into the human body, then that means that you would have less downtime in the operating room, in the hospital after your operating session. So we're gonna quickly explore how we're gonna go from simple CT scans, which are 2D, to something a little bit more elaborate, such as the 3D airway reconstruction. And this is not brand new knowledge. You could search this online, you can find open source code for this. But a robot integrates a lot of different technologies. So we'll briefly brush over these areas, but I wanted to show this image. So we're taking 2D slices. Think of it, analogy would be like a book. You have multiple slices, and from all these 2D slices, you can construct a thick book. But what do you do with it afterwards? How is that useful for a surgeon in the operating room? Well, you want to construct a 3D model. So you're going to need a huge data set. You're going to need a really good algorithm, and you need to test it. So I know this is a little blurry. This is another way. On the right-hand side, you have 2D slices. Left-hand side, that is what the camera would see inside the human body when it goes down the trachea. And then this is the 3D rendering of the model of that person's lungs. And this ball, that's the suspicious mass that may or may not be benign for cancer. So, when we talk about visualizing model output, the modeled output for a lot of machine learning models, it's more than just a coordinate because it's almost like a moving target for the physician. Even if you go into a procedure and you're put to sleep, the human lungs are extremely intricate, and everyone's lung set is unique and it's not symmetric. Therefore, your model needs to be extremely robust and well-trained. And especially with hospitals, which may or may not be open systems, you might not have internet connection. So your model is going to sit on a robot in a hospital that may not be with the most recent software, so your software needs to be pretty much perfect. So I'll briefly get through an example of a system. We have different ways that Python and just software code in general is used throughout the entire cycle of this. So when I say pre-op, that's the part where you get a bunch of MRIs, CT scans, whatnot, which is prescribed to you by the doctor. The idea is that you can get these scans, and the doctor will feed into the algorithm, the robot, and from there, we'll have algorithms that create a 3D rendering of your particular lungs. From that, a plan is created for the doctor to navigate down your lungs through the bronchoscope, and the physician could customize the plan. So what that means is once it's decided that you will go into procedure, it's called intra-op, and that's where this robot in the middle comes in. This is one of many examples of what's out on market of different types of robot-assisted surgeries just for lung cancer. And then finally, afterwards, there's the post-operative analysis. So for intra-op, we're briefly getting to what are we talking about. So bronchoscope goes down the trachea, and it's navigated by the physician, and it's steering itself through tension wires. And this blue thing goes down the throat. And it's so thin, it's thinner than a pencil. And the tension wires navigate down through your lungs. So not only that, this bronchoscope is attached to the cart through the attachments. From there, we have the tower, which are the brains, which controls all the movement. And we also have the controller that the physician is using. So if you notice something here, the physician still has eyes on the patient. They have eyes on the camera that's going down the lungs. They have the 3D rendering. They have the pathways to guide them as they steer down the human lungs. They have the CT scans for each area where you're traveling down the human airway. So when you think of all this software code and its millions and millions of lines of code, when we talk about Python, this is sort of like a mirror of what would go on during a surgery. The real-time telemetry, depending on what you're using, would help the doctor to make sure that they're not getting too close to one side of the lung wall, and they're going straight to the pathway that leads to the potentially cancerous mass. So these are some of the many libraries and packages that are really important for this type of work. So DICOM stands for Digital Imaging and Communications in Medicine. It's similar to an international standard for medical images and its related information. There are already existing ways to unpack images, to transfer them, to track them. There are also a lot of different ways to handle everything from the imaging processing as well as to the data handling and the visualizations. So we briefly did a case study about what goes into this entire robotic system, but there's still a lot of work to be done. It usually takes years for any clinical drug to be approved by a local government. It's even harder for any medical robot to be approved. So when we talk about lung cancer as a global problem, but also an area of great opportunity, the idea is that when we talk about the software that goes into it, we have to be diligent about what we're using, and we have to understand it well enough to address problems that we talked about earlier about the data fusion, as well as the UI, the camera issues, also end of life. And then obviously, as more and more conversations come up about usability of AI, we've been using algorithm for years. It's just nowadays it's called AI. But within the world of medical robotics, it's heavily regulated, and oftentimes the regulations are stricter than AI regulations as they exist today. So the idea is that as problem solvers and engineers are going about your work and doing your contributions, this is where it goes towards. And hopefully, in some time in our lifetime, those really serious statistics that we showed for lung cancer in the world get a little bit better. So thank you, everybody. I really appreciate you hanging on with all the technical.
Thank you very much. So, any questions? Yes.
Hi, thank you. That was very informative. I was, let's say, working in a medtech company like 7 years ago in a very similar case study. So our main struggle back then was how do we collect data? We had some cooperations with hospitals, but our main struggle was, in data annotation and data collection from, experts. How do you, let's say, cope with this? How do you, let's say, structure your data strategy? How do you get quality data? Yeah.
Thank you for the question. So my understanding is, how are you getting your hands on large data sets which are annotated and good data?
Yeah.
This is the ongoing problem. I can tell you for now, what works for now is partnering with universities and hospitals so that you can get consent from patients to use their data for training models, because there's a lot of regulation about that. And as we go forward, there are open source data sets available. The quality is to be determined, and with different shifting policies across the world, that might not be an option anymore. But right now, partnering with institutions that are well established has worked. Thank you.
Just one more. There can be, let's say, quite a conversation about annotations. So, have you ever used any active learning, let's say, methodology to, let's say, increase your model hit rate with less annotated data? Or, let's say, find what data to annotate next?
Oh, this is a good question.
I mean, active learning is a very special domain. I'm just asking.
I think that it is an area for exploration. For some governments, whenever you change specific methodologies, you have to go through approvals, and you're audited very strictly. So it has to be an analysis of the cost and benefit for every step, because if you break the code, you're shut down. So there's a lot of consequences and domino effect that you have to balance out and test internally before you can state, yes, we want to go through and collect more. But I like this idea. Thank you.
Hi. You alluded to this a little bit, I think, in the response, but is there any sort of global agreement on how these different software implementations, XAI, things like that, or is it really just sort of a case-by-case, country-by-country basis right now?
This is a good question, because there's no global universal solution. Every country governs its citizens' rights very differently, their data privacy, data sovereignty, and they have different ways of ensuring safety for their citizens. So, I mean, depending on how you see it, that's good for the people. I think it's harder for companies, but I think the regulation is a good thing, because that's someone's life. So.
And does that difference stop technological innovation and implementations that have been working in one country from being brought to another, or is there allowances for things that have been proven to actually work?
I think it slows progress to a pace that you might not expect for software, but I do think that companies that have good intentions and are determined to help people, they will go through the extra growing pains of those 10, 15 years of doing it the right way for the patient's safety.
Thank you. We do have time for one more question. Anyone? No? Okay. So thank you very much, Illinois. Okay. And I have 3 announcements. So now we will be having a lunch break. The lunch is served at the sponsor area with a 60-40% analogy of meat and vegan options. Tables are also found on the first floor of Innovathens, and also we'll be having a t-shirt pickup happening during and after lunch. And there is also the lightning talk registration, which is still open, and so if you have any idea you want to share, you can share it with us. So thank you. Okay. So welcome back, everyone. I hope you enjoyed your lunch. So we will be continuing our talks with Adonis, and he will be talking to us about event sourcing. So let's give him a warm round of applause.
So let me try this. Is that okay? Okay. So, hello everybody. I'm very happy to be here with you. This is the first PyCon in Greece, so it's really an honor for me to be here. Well, my name is Adonis Markoulis, and I'm currently a senior staff engineer at Orpheum. Today, I want to share with you how we can solve complex distributed systems problems, and we will use event sourcing and CQRS by familiar Python tools such as the Fast API and the Celery. So, let's start with a real-world problem. And this is a classic nightmare, and probably this sounds familiar to many of you. On Monday, we have a report, and there's a user that's been missing. So Sarah's account has been missing. And after lots of debugging, we lost the whole day. And on Tuesday, we still haven't been able to find out where is Sarah's account. So what's the problem here? The problem is that usually in the classic architectures, we usually have one row in the database for each entity. Okay. Is that better? Okay. So, what happens? What happens is that in the worst case scenario, usually this row is deleted, so we cannot track anything. On best case, we have a kind of soft deletion mechanism. We might be able to find when that deletion happened. We might be able to find who did it, but for sure we lose the why. And this is very important. So let's say that we have a system that doesn't have the full memory of what happened. And this is a huge problem on many cases. So this is where event sourcing comes into play. And usually event sourcing is combined with the CQRS pattern. What's very important in event sourcing is that we store the events, and the events are the facts. We don't do any interpretation of what happened. We just store the raw event which states the change in the system. With the CQRS part, we have the separation of concerns. So we let's say, perform the writes in one database and the reads on another database. And those two, event sourcing with CQRS, they combine very well together. So let's go back to those events, those facts. How would this event look like? Well, the event is the one you're seeing on the slide. So probably we'll have an ID of the event, the aggregate ID, which is the user ID that was affected, the type of the event, the timestamp, the schema version, the revision, and also the data. As you can see, we have everything that we need here. We have the full facts, and those facts that never change. So, how about where we store those events? Usually, what we have here is we have the event store, and the event store is an append-only storage. We organize the storage usually on streams, and we have a different stream per each aggregate. So, for example, if we wanted to see the stream of Sarah, we would have a creation event, then we would have some update events, and finally, we would have the deletion event. So this is the full stream for Sarah. So, what are the characteristics of this stream? Well, it's an append-only stream, so we never update or delete any event. We organize per aggregate. We can replay those events at any point in time and go to a specific timestamp. And we usually mention this event store as the write model. Overall, this stream is the source of truth, and this is all that we need to store effectively. Now, let's go to the world of CQRS and start with the commands. The commands, they represent the intent to change the system state. So, if I want to create a user, I will have a create user command. If I want to change a password, I would have a change password command. The characteristics of the commands are that they express what we want to happen. They have basic validations of the payload that they carry, but also of the fields that they need to have. They're idempotent. This means that we can apply them as many times as we want. And usually, they are the entry point for the whole procedure. So it's the starting point for when we want to change the system. Overall, they present what we want to do. And on the other hand, we have the queries. And the queries, they represent the intent to read data from the system. For example, we might have a get user account query, or we have a get all users query. The characteristics of the queries themselves are that they are read-only, so they don't alter the system state. They use different models, and this is very important, so we don't query the events. We use a different model, and this is where the CQRS comes into play. And those new models, they are optimized for the specific access patterns. So usually we can have denormalized databases, we can have specific indexes that are just proper for reading. And this is the whole concept. Different models for different purposes. How about the business? Well, the business, it's on the aggregates. And the aggregates, they contain the domain logic, and their main role is to produce new events. So, for example, validations such as an email needing to be unique, or a too short password, etc., those belong to the aggregates. And those aggregates, they have two main roles. First of all, they get up to date by applying events, but they also have business logic methods in order to apply the business logic and produce new events. Now, the final part, this is the projections. And the projections are the entities that actually are being used in order to build those read models. So, for example, if I have an event that a user has been created, I might have multiple projections on this one. So I might have a projection that actually creates the user model, the read model, but I also would have a projection that's about sending an email. So I would create, I would say a welcome, I would send a welcome email to the user. So the characteristics here are that the projections are event-driven, so they're triggered by events. We can have multiple projections per event, and the most important, they are eventually consistent. So they are updated asynchronously on the background. Now, how everything works together. Everything usually starts from an API, and we have two different, let's say, flows, the write flow and the read flow. Let's start with the writes. And for the writes, what we have is that we need to find the proper command, and each command, it has its own command handler. This is one-by-one relationship. And the command handler orchestrates the process from this point on. So we have the command handler finding the correct aggregate, and then using it in order, getting it up to date, and then using it to create new events. And those events then have two destinations. First of all, the event store, the right model that is, so we store those events, and then we also have the event bus. And this is where projections come into play, because they can get those events from the event bus and ultimately update the read model. So this is how the writes behave. When it comes to the reads, we start again from the API, and we need to find the correct query. And then each query has its own query handler, and this is again one by one. So the query handler is the one that interacts with the read models, and we can retrieve the data from the read database. So we have same APIs, the same entry point, but two different paths for writes and reads. We're in a PyCon, so let's show some code here. And I'm going to start again from the API part. Luckily, the ecosystem of Python, it offers a huge variety of APIs. I'm going to stick with Fast API because it's very, very fast, and also because it's very agile. We can adapt any kind of architecture we want in it, and it's really easy. Also, what Fast API does very well is that it connects very well with Pydantic. And we can use Pydantic, which is a very, very powerful tool, in order to handle the payloads, the queries, but we also can handle the commands and the queries. So everything is a Pydantic model. And this gives us out-of-the-box validations and other checks. So, as you can see in this slide, we have the two different paths. So we'll start from the first one, the right one. All we need to do is to leverage fast API's dependency injection mechanism. So all we need to do is to pick the proper command handler, populate the command from the payload, and then we can call the handle method of the handler. And that's it. Very minimal API, very thin layer. Same applies with the API for the reads. So we just need to get the query handler from the dependency injection and call its query handler. That's all that is in terms of the API code. Very, very minimal, very, very thin. Let's deep dive now, and let's see how a command handler looks like. Well, a command handler is a classic Python object. It's a Python class. And usually, all we need to implement there is the handle method. And the handle method, it takes one command. So what we need to do in a command handler is to, first of all, retrieve all the events for the specific aggregate, apply them to the aggregate so the aggregate is up to date, and then call a business method in order to produce the new events. Then we need to send these events to the destination. So we have the storage to the event store, and also we have the dispatch to the event bus. Usually here we might use a unit of work pattern because we want this to either succeed as a whole or fail as a whole. How about aggregates? This is where the heart of the business lives. Yet again, the aggregates are pure Python classes. So the aggregates usually, what they have is they have an apply method, which takes events and applies them in order to make the aggregate up to date. So in the apply method, we would usually have a long else if, let's say, mechanism in order to apply the proper business logic method. What we also have is the business logic itself. So we might have a change password method here, where we run the validations, the business logic, and we will check whether the password being very, having too many characters or too low characters. But we also, this is the part where we produce the new events. Now, let's go to one of the most interesting parts of this whole code organization. We need to send the events to the event bus. And this is where Python, it offers a really, really powerful tool, which is Celery. Celery is a distributed task queue. And how we want to use it? Well, what we want to do at this point is, first of all, to add the messages to the event bus, but we also want to somehow trigger the projections from those events. And Celery is very good because it can do both at once. So you can see my Celery event handler. All we need to do here is to implement a dispatch method, which actually what it does, it iterates over the events that we want to dispatch. And for each one, it reads the configuration where we have which event maps to which Celery task, and it just calls the Celery tasks. So this is very, very powerful, and it enables all the async processing within the projections. Now, how about the Celery tasks themselves? Well, this is the code of Celery task, and you can see the same patterns that are being applied in the API layer. You can see the same patterns being applied here. So what we have here? We have a dependency injection mechanism. Unfortunately, in Celery, we don't have the depends. We don't have this kind of functionality. So we need to do the dependency injection manually. So what we want to do here is to get the infrastructure factory and from it retrieve the proper projection. Once we have the projection in our hands, what we need to do is to call its handle method and pass the event. It's really, really easy. The code is really, really minimal. You can see in this part that we have to use an async to sync method. Well, this is some magic because Celery doesn't actually support asynchronous code at this point. So in order to run asynchronous code, we don't want to write both synchronous and asynchronous code. We have one flavor. So in order to run asynchronous code from Celery itself, we need to use this async to sync. Other than that, we have a very, very reliable mechanism of processing the events. What's also interesting about Celery is the fact that it offers a huge variety of capabilities. What's the worst that can happen in event sourcing architecture? It is to lose an event. We cannot afford to lose events. And this is where Celery comes into play, because it's really easy to implement retry strategies. We can implement late acknowledgement patterns. We can implement jitter in order to not have all the retries at one time. We can also have exponential backoff. So all these things, they come naturally from Celery. We don't have to write any code. We just need to configure. And this is what makes the whole architecture very, very powerful. And this is why we need to use it. So this whole combination of AXLate, retries, and it can handle all the real-world failures. Now, one last thing about the code itself. This is about the projections. So, as we said before, the projections, they are triggered by the Celery tasks. Let me go back to this one. So you see the handle method here on the Celery task. So the handle method, all that it needs to receive is to receive an event, which is, let's say, a user-created event in this case. And then we need to use a repository-like pattern to just take this event and store it to the read model. So this is how we update the read model. Yesterday, I think, or the week before, Celery also supported pedantic models. So this is a huge win, because we will be able to somehow make this part, because at this point you can see that I was passing the event as a string, as a dictionary. Now this is fixed, and we can also use pedantic validations in the Celery tasks themselves. So this is really amazing. Overall, as you can see, the projections are being tackled asynchronously, and they update the remodels. So this is why we do the database save of the user data. Now, this is how everything wraps up. So we have the commands being calling the command handlers, the command handlers using the event store to retrieve, to get up to date the aggregates and produce new events. The events that are then triggered to the two destinations, the event store, the event bus. From the event bus, we have the projections, and the projections update the read model. And this is the full life cycle. Now, let's go to the most interesting part. What about reality? You can see that the code that I described is really, really simple, and it makes sense to apply it. It's really easy. Well, in reality, things don't go that well. And we have lots of issues. I can talk for an hour about issues that we'll face with production, with event sourcing. However, I have decided to focus on 3. And let me start with a nightmare, the eventual consistency. So let's start with an example. We have Sarah. I really love this name. And Sarah, she wants, again, to change her name. And she wants to remove that extra H. I know sometimes we write it with an H, sometimes we don't. So Sarah wants to remove that H. And of course, we have a form in the front end, and Sarah edits the name, and she hits the submit button. What happens is that when she hits the submit button, nothing erroneous happens, and the screen refreshes. And Sarah sees again Sarah with an H. And she's really confused. What's going on? This is the classic problem of eventual consistency. And it happens not only on event sourcing, but in other architectures that usually have async processing. So what's happened on the background? What really happened is that even though when we hit the submit button, the actual event was populated and it was stored in the event store, and this is why we got the successful response, the read model didn't get updated. And the front end, after submitting the form, it called the backend in order to get the new user. And the user hasn't been updated because the projection hasn't been executed. So how can we handle this one? Well, I've seen 2 approaches. Let me start with the most, let's say, naive. And this is called optimistic updates. This is something that I really like because I don't have to do anything as a backend developer. Everything happens in the front end. And what actually happens here is that when we hit the submit button, the front end, in the case that it receives a successful result, it says, well, the event has been persisted. Eventually, this will happen. So let me act as if everything works as planned. So the front end doesn't perform the GET request, and it shows the updated value. So everything works like a charm. I know you're probably thinking, what happens if a user refreshes manually the screen? Normal users, and I don't mean QA engineers, I mean normal users, don't do that. I didn't have such a case. But also, what we actually want to do at this point is that we want to make sure that our, let's say, consistency is consistent within some seconds. And we might have an SLO for this one. So we might count how much time it takes from writing to the event store to updating the read store. And in simple applications, this can be 5 seconds, 8 seconds, something like that. So the case of forcing an update and doing this in less than 5 seconds, well, it's pretty, let's say, it doesn't happen. Now, let's go to a more, let's say, advanced technique. What if our update of the read model, it takes hours to be performed because we want to run a machine learning algorithm in order to update the read model? And the projection is very, very complex. This is where we use the outbox pattern. And you can hear the outbox pattern a lot because in other architectures that don't have Celery, they use it by design. But what we actually do here is that we have a table in the database that has each event and whether it has been processed or not by projections. And what we do here is that we expose this table to the front end. So the user, he can see or see what's the status of this projection. So this kind of, it alters the whole nature of our application because the users, they need to know that everything that you do is managed on the background. So this changes the experience. And in many cases, this is totally acceptable. So overall, there's no solution to the eventual consistency issue. We just need to have thoughtful UI design and work together with the product team and pick one of the two solutions. My favorite one, the performance issue. Well, as we said in the beginning, the event store is an append-only storage. So as time goes by, we tend to accumulate more and more and more and more events. So, and this does never change. So what we have here is a classic example of slow performance. So let's say that we have a user that he wants to change his password, but he's a very active user. He has lots of events on his event stream. So what we need to do again is we go to the command handler and we pick those 10,000 events, and then we need to apply 10,000 events. This takes 5 seconds. And 5 seconds for a password change, well, this is totally unacceptable. So how can we tackle that? Well, the solution to this one is snapshots. And how do we handle snapshots? Every X events, we just store in another database a snapshot of the aggregate itself. So for this specific case, what we would do is that we would get a snapshot of this user and only apply the remaining events. And this is very, very agile because it is up to us to select how soon we will get a snapshot or let's say if we have multiple snapshots, and this whole thing depends on us and we have all the capabilities to do so. So in this case, we'd only have to apply, let's say, 50 events, and this would make the performance from taking 5 seconds to milliseconds. And this is how we can solve the whole performance with the snapshots. Overall, it's a very safe way of rebuilding the state efficiently. Now, the third one. Let's go back to the first slide, because we had an actual problem. We lost Sarah's account, and we were not able to find what happened. So this is where event sourcing thrives, and it's on debugging. So what happens here, you can see the timeline. So we have the Sarah's account reporting to be missing, and then we can do what? All we need to do is that we need to get those events from the production database. If we have those events, we can make the debugging story into a unit test. How is that? We just need, you can see that I'm using a PyTest test case here. What do we do? Well, we initiate a user aggregate, a user, so we have Sarah. We apply the events from the production, and we get to the point where the event is supposed to be applied, the deletion event. We can then apply the problematic event, and we can assert the state after the event, so we can know for sure what happened. We can do that very easily just by applying the events, and we don't need any kind of infrastructure for that. This can be tested in isolation, and we can have thousands of tests like this. What's really important here is that we can test both applying problematic messages, but we can also apply the business logic methods. So it's really, really easy to test the core of our application without any involvement of infrastructure. So finally, what's really important is that we can make the debugging a test case. And we can even predict bugs by using this one. Just by applying random events from our database, we can create real test cases. And finally, the time travel. We can go at any point in time and debug. So we're not able only to debug what happened now, we can go in the past. And I know Monday is, let's say, very close to us, but we can debug what happened 2 years ago. And this, for systems that require auditing, well, it's really, really important. Now, let's perform one summary. First of all, you can think that I didn't mention anything about infrastructure. I didn't mention anything about databases, about event buses, about anything. Why is that? Well, personally, I believe that we need to start simple. We don't have to use fancy event stores. We don't have to use Current or Event Store, it was called. We don't have to use Kafka. We don't have to use MongoDB in order to be our read database. We don't have to do that. Start simple with technologies that you know. And on 90% of the cases, this is more than enough. And if it happens that you cannot, that they're not enough, you can easily switch because the architecture is not, it allows to do so. So another thing that I want to add here is about Kafka. Most of people are using Kafka in event sourcing because it combines the event store with the event bus. This is a counter pattern. Don't do that. Now, is event sourcing the solution to everything? Not really. If you just want to create a simple CRUD API, don't use event sourcing. Probably logging is enough for you. You don't have to use event sourcing. Also, if you have a trading system, which is high frequency, and it probably requires immediate consistency, I would advise you again to not use event sourcing for this kind of systems. Finally, and most important, if you have a team that doesn't have experienced people, I would again advise you to not go to event sourcing because it has, let's say, it needs too much of experience. So I would advise to start with a proof of concept, test what happens, and then move on to actually implementing this one into production. However, if you're not on these three cases, go for it, because you will gain complete audit trail, and you will also gain the time traveling capabilities. You have debugging superpowers. You can go anytime with real production data. And you also have the scalability because of eventual consistency. You can have multiple workers working on the background. You can have everything like that. Finally, you can use Python. The ecosystem, it does provide you with everything that you need in order to implement, so you don't need to go to Java. Python has everything that you need. Thanks a lot for everything. You can find me on GitHub, but also on GitHub I have a full example, a full implementation of an event sourcing pattern, so you can see how this can be applied. So feel free to see the whole pattern. That's all from me.
Thank you very much. So we do have 1 minute for any quick questions for anyone.
Okay, you said that using Kafka both as an event store and an event bus is counterintuitive.
Yeah.
Why?
Because you cannot have the separation of concerns. Oh, sorry. Yeah. Because you don't have a separation of concerns, but also you might end up with issues in disk space with Kafka. Because storing this whole series of events in Kafka is not designed for for storing this amount of data. It's very performant in terms of throughput, but once you have 10 millions of events, it becomes problematic. So it might require more space, etc., more provisioning of resources. So this is the reason behind that.
Okay, thank you.
Thank you very much once again. So we continue with the 5-minute break for the next speaker to prepare.
Hello. I will need sound. Yes. Is that just this cable?
Yeah, just connect.
You just connect. I would like to ask you.
You might probably, yeah, on the ground, it fell down. It's this one.
I also need sound, and is that just this cable?
Yes, this is the sound, sorry. Just try to manage it so it doesn't fall down.
All right.
And this is for sound. On this side. Like that. And we need to do a quick sound check. Can you play something?
Maybe. Let's check. Let's see.
For playing? Yeah, you probably need to raise the volume in system.
Let me check if it's on the... Yeah. Perfect. Okay.
Have you included the 5-minute slot for Q&A?
Yeah, I think I will not go over 20 minutes. I don't think.
I will be notifying you with some, what the time you made on the 10 minutes.
Mm-hmm. Yeah, for a second. left.
It's okay if you don't. Just whatever is less stressful for you.
All right. Can I start? No.
So we will be continuing our talks with Donatas, and he will be talking us about the art of do repeating yourself. So please give him a warm round of applause.
Good afternoon, everybody. So nice of you to come out to this talk. For the next 20 minutes or so, I'll be talking at you. But before I do, I want to make some disclaimers about this presentation. Mainly, I want to do that to set some expectations of what you will get, also what you will not get. But I also really want to encourage a certain way of consuming this presentation. Disclaimer 1, there is no learning here. I have no advice, I have no best practices, I have no tricks, no tips, no life hacks. You are not allowed to learn here. If you have your notebook open, a laptop, anything to take notes, feel free to close that. You're not going to need it. The slides have nothing of substance. There's no need to screenshot them or film them. No learning. My goal here today is hopefully to be somewhat entertaining. With a bit of luck, I can get you to scratch your head a bit, maybe laugh a little. Ideally, you leave a tiny bit inspired, but no learning. Disclaimer 2. I've done this presentation before, once before, in Lithuania. And it was, to my idea, a disaster. And so I rewrote the entire thing from scratch, which, in a way fits on a meta level very much with this title of the presentation of Do Repeat Yourself. So that's fun. Which brings me to the final disclaimer. This, what you see here, is not Impress.js. When I say I've written everything from scratch, I mean I've built this software to present this presentation specifically for this conference only. The last 3 days, I've slept very little, I've eaten very little, I had lots of anxiety sweats. This is a presentation built on tears and no sleep. Given that it's written in 3 days and it's written by me, there's a very high likelihood that it will crash. I apologize in advance, and I hope we can get past it together. Now, to explain why I want to talk about repetition, I have to explain a bit about why I want to talk about repetition. And for that, I want to tell you a bit about language learning and how I think about language learning. Not specifically programming language learning, just general language learning. I think languages afford us quite a lot of things in the way we interact with the world. The thing that I don't want to focus on are the kind of active or direct benefits of learning a language. So you learn Greek, you have an easy time ordering food and getting around Athens. You learn Python, you know how to write instructions for a computer. To me, that's not all that interesting. What I want to focus on is something that's a little harder to define or grasp, kind of the intuitive part of languages. If you ever learned an instrument, then at some point some musician with like 20 years of experience probably came up to you and saw you struggling on your drums or your guitar or whatever, and just looked at you and said, just gotta feel the music, man, which is a totally unhelpful thing to say to somebody who's learning an instrument until you finally feel the music. And then you're like, yeah, man, feel the music. That's kind of the thing that I'm looking for. So what does this kind of intuition look like in Python? And to me, I think there are two dimensions that I care about. For me, it is the way you perceive the world and the way in which this language intuition forms your personality. So when I say the way you experience the world, right? Like that's not in your IDE, that's just when you're out and about in every regular, everyday situation. How does knowing Python affect how you interact with things? Well, I think one sentiment that is very prominent in programming in general is this idea of breaking down problems into smaller, manageable parts. I used to teach Python quite some time ago, and at the time, I always said, in order to become a good software engineer, you have to learn to break problems down into smaller parts. By now, I'm not all that convinced of that anymore. I think it's more the other way around. I think it is that because you are writing Python and because you are programming, you gain this intuition of how to break things down. Similarly, I think debugging difficult problems, like really diving into some obscure issue, is something that really empowers you in introspection and self-reflection. So it allows you to look back on your own life, on interactions that you've had. And in general, the explicitness of programming, I think, is super beneficial in how you communicate with people. So many understandings come from vague communication, not being explicit enough, not being to the point enough. Well, a computer does not understand. It's going to throw an error at you. It's not going to, pretend to understand, but actually didn't understand, and then you had a fight later on. I think these things give you a different way of engaging with people and the world around you. The second dimension I want to talk about is how an intuition for a language forms your personality. Like, how does engaging with Python more or repeating something more form the way you engage with that language, or how you write it even. You know how when you're writing in your regular language, whether it's Greek or English, some things just feel better than others. Some things feel more you than others. There are certain mannerisms, there are certain sentences that you just continually return to because they are you. The same things happen in Python, I think. You find libraries that you really love. You discover ways of writing code. Maybe you're really into typing. Maybe you're really into Jupyter notebooks, whatever. It all kind of defines your personality, and you become so convinced of how good that is that you get into flame wars on the internet about, what's better, polars or pandas. But to me, there is no best personality. Like, there is no good or bad way of doing it. I think the only bad thing would be to have no personality at all. And so, with all this, we have covered a bit of why I want to talk about repetition, because, believe it or not, my preferred strategy to build Python intuition is repeated engagement. Repetition generally gets a bad rap with developers. There's even this principle of do not repeat yourself, which is what I modeled the title of my talk around. But I think repetition can be fun. I think sometimes the next time it's even more fun than the last. From repetition, we get a certain knowledge. We get a familiarity with a domain. We kind of know what to expect. We know what comes next. You also find out what you don't know yet. But from this safety, we get a confidence to go into these things that are maybe unfamiliar to us. You tackle problems more confidently. You tackle bigger problems. If we do enough repetition, we also get faster. Increasingly, we get a certain rhythm in our work. We don't get stuck on the same problems. We don't have to look up for the 50th time how to center a div. At some point, you just know. And all of this allows us to engage more and more with complexity. Complexity, to me, is not the enemy, which also I think is not a very popular sentiment in developer communities. Generally, it's all about simplicity. But to me, it is in complexity that we get these aha moments of suddenly you feel the music. This being a Python conference, we're going to switch to some code now. You'll see how it works out later. I'm going to breeze through it a bit. I hope you understand why in a minute. I recently learned that you can use NumPy to generate music because sound is just waves, and waves are NumPy arrays. So if we're going to make something like a drum beat, we basically create a pure wave of a low frequency, like the higher the frequency, the higher the pitch. Then we have to apply this thing called an ADSR envelope, which, if we focus a bit on the A and D, attack and decay, for a drum beat, it's like this loud thud. So the attack is really quick, and the decay is really quick, and that's how that sound wave ends up looking. Then we do this very weird NumPy stuff to actually create something that can be turned into sound. And then we run it. Should be playing, unless the sound is off. So there we have it. A little bass drum in the background. Okay. Well, I guess we saw this coming. Give me a second. I luckily know why. Let me mute this while I fix it. All right. Let's hope it does not happen again. Where was I? Right, so my favorite strategy of cultivating intuition is repeated engagement. I think repetition generally gets a bad rap with developers, it being boring. But I think repetition can be a lot of fun. oftentimes the next time is even more fun than the last. What we get from repetition is a certain knowledge. We get a familiarity, kind of see what's gonna come ahead. We know what to expect. And so we know where to go next, what the next unknown is. That familiarity gives us a certain confidence from which we can go into these unknown problems. We can tackle more difficult questions. And as we repeat more and more, we become faster. We go through our talking points faster. We don't need to spend as much time because we already know certain things. We get less stuck. And all of this is so that we can engage with complexity more often and with more complex complexity. Because to me, complexity is not the enemy. Complexity is very much the goal. Complexity is where we get these aha moments where suddenly we feel the music. All right, let's dive into some code. I'm going to breeze through it a bit. I hope you will understand why. I recently learned you can make drum samples with NumPy, and all drum samples are really similar. So we're going to make a drum kit. So we define some frequencies for various parts of the drum kit. Then we apply this ASDR envelope depending on the instrument. And finally, we do some more magic, combine it into a composition, and we play it. It should be playing. Huh, thanks. So we have a little beat going on. Right. Guess we saw that coming. I know why it happened though. Let me pretend to fix it. All right, where was I? Repeated engagements. That's my preferred strategy for building intuition. Every time we come back to something, we kind of see something new. We learn something new. And repetition often gets a rap for being boring. I think you can repeat something quite often before it gets dull. What we get from repetition is a certain familiarity. Kind of start to think, we know what's going to happen. We know what's going to come. And it gives us this certain confidence to tackle problems. And we start to speed through our slides or whatever it is that we're doing more and more. And this allows us to engage with complexity more often, because it is in complexity that we discover variations and things that we did not know before. We find things that we were not even looking for. We discover libraries, we discover other ways of doing things. And if we discover enough, suddenly we don't just feel the music, we also feel the code. Let's make some music. So, from what I know, you can make music with NumPy. But to be honest, I've spent quite a lot of time on this, and it really kind of sucks. There are better ways. In my case, for this specific presentation, I used PyDub. And so let's make something a little more melodic. Let's play a key. Wanna guess what happens next? All right, I'm gonna do it one last time. Repeated engagement. or repetition. Is my preferred way of building intuition. I've built this software twice now, and I look very much forward to building it a third, a fourth, a fifth, and a sixth time from scratch over and over and over. And I know it will be different every time, and it will sometimes suck more, and it will sometimes be better. Because I think the more often I repeat it, the more complex it gets, and the bigger the chances that I will stumble upon this intuition. Because intuition comes from this complexity. It are these moments where it suddenly just clicks. It's not a structured approach. There is no code academy to gaining Pythonic enlightenment. And I think repetition is the thing that gets us to this point of complexity. Every time we return to a problem, every time we return to something we did, you find something new. This is why people are so obsessed with rewriting in Rust. It's not because it's Rust, it's because it's rewriting. And that's the interesting part. And to finish, I want to end with the hottest takes of all, which I guess is very much the theme of my presentation implicitly. But I very much disagree with the Zen of Python. I don't think simple is better than complex. In fact, I think it is the opposite. I think complex is much, much better than simple. Thank you.
I think we will be needing you for the social event at night. So thank you very much.
You're welcome.
Do we have any questions for Jan? I guess.
Hi there.
Hi.
Thanks for the plot twists in your presentation. You basically advocate that repeating yourself is a good development method. But what happens once you're through with that? You repeat, you develop, you reiterate, you write everything in raw scripts, or you don't create abstractions.
Mm-hmm.
You're done with that. You want to develop what it is you want to develop. Do you stay there?
I think there is...
And the questions are so the keywords here are maintainability, reusability, and when you share your code with others.
I think the way that I look at it is when you get to this point where you have repeated something many times over, I think the product that you are sharing with people is going to be far nicer than what you can do by dividing yourself into like many different things. I think the thing that it's a difficult question, right? Because on the one hand, I get what you're saying. You cannot be infinitely repeating something.
Not only that, but because at some point you might leave your code, you will return to it, and you will not be able to debug because you fix one of your many repetitions, but then you have to fix all the rest.
Oh yeah, in that sense, I very much advocate for throwing everything in the trash and writing from scratch. And then, in my experience at least, every next version of software that I make is going to be significantly better. Like, there's still a million ideas I did not manage to implement here, but it's leagues ahead of what I did in Lithuania with this presentation.
Thank you.
Thank you. So any other questions? No? You can catch Donatas later.
Yes.
So thank you very much once again. We will be having a 5-minute break. Okay, I think we can continue. So the next speaker will talk to us about Python enhancement proposals. So let's join on stage Nikos. Thank you very much.
Good afternoon, everyone, and thank you for coming to my talk. Today I'll talk to you about the role of Python enhancement proposals and how they help Python evolve throughout the years. So before I begin, a few things about myself. I'm Nikos Ngouras. I'm a software developer and an electrical and electronic engineer. And I currently work as a research and development software engineer in Public Next here in Athens. So let's begin. So in this talk, I'll go over what exactly are these Python enhancement proposals and why they matter to, and they should matter to us as a community. The life cycle of a given proposal, what it goes through, as well as some historical examples about some important PEPs of the past and some things we're coming from those. Lastly, I'll go over how the community, each and every single one of us, can participate in this process and build a better Python for the future. So what exactly are these Python enhancement proposals? Essentially, each proposal is a document. So when someone comes up with a great new idea for Python or some feature or something they want to add to the language, they need to convince everyone else that it is actually a good idea and it is useful. So they come up with a design document that they then submit for review to the members of Python, excuse me. This is then used to as a basis to build upon Python and improve it. Also, something very useful about these proposals is that they are logged and cataloged. So there's always a clear history of how Python came to be what it is today. And it's very interesting actually to go over some of them yourself and look into them. So these proposals can be categorized into three main types. First of all, it's the standard proposals, which describe some new feature in the language or improve upon an existing one. Then there's the process track, which has to do with proposals that have to do with the processes surrounding Python. For example, PEP 1 is the one that has to do with what exactly describes what PEPs are and the guidelines for creating these documents. And then there's the informational types of PEPs, which is essentially used to communicate some information to the Python community. For example, PEP 0 is an index of every single PEP. No worries. Then if you want to find a PEP, you usually go through PEP 0 and you can find a list of them. So let's go over the life cycle of a proposal. But before we do, I'd like to go over some of the key players when it comes to such a proposal. So it all starts from an idea that someone has, maybe a cool new feature or something that they want to change about Python. And it has to be some kind of major change that they want to propose. This person, also named the PEP champion sometimes, is the one who proposes this change and is responsible for this document throughout its life cycle, for gathering feedback, improving upon it, and going through it from start to finish. Also, once someone has an idea, they also need to get someone to champion their proposal. So they usually have to sponsor, the proposal. So they usually have to pitch the proposal to a core member of the Python community, and they would have to sponsor this idea so that it can move forward. There's also the steering council. So this council didn't exist until 2018. Oh, sorry. Thank you. Up until 2018, the creator of Python, Guido, was the one who had the final say in accepting or declining any new changes to the language. Until 2018, when he stepped down as benevolent dictator for life, as they called him. So he had the one who had the final absolute say for the language. But in 2018, he stepped down, and a council was created instead, which is called the Steering Council. This council is comprised of 5 members, which are voted democratically from the Python core team members, or the core developers. Also, sometimes this steering council might appoint a delegate for a specific PEP. So someone who's usually an expert in the field and can help with the process of the proposal and give feedback to the champion of the proposal. Lastly, there's the community. That's all of us who can participate in, so Python is an open source language, so the community is welcome to participate and provide feedback and go through this process along with every one of these core developers. So what does the timeline of a proposal such as this one look like? So as I said earlier, first it starts with an idea that is usually discussed in some kind of Python mailing list or a forum, and this is sponsored by a core developer. Once this idea is sponsored, the champion of the idea has to come up with a draft, a document pretty much, that has strict guidelines, and this has to be accepted by some editors of Python. Once the proposal is accepted, then it's put up for review. So this can be a long process. It can take a few months, it can take a few years, but there's a lot of back and forth, lots of iterations, lots of revision cycles to make sure that the proposal is actually in a good spot and it's actually an improvement for Python. So once everything is done with this revision cycle, we move on to the final decision. This is done by either a member of the council or the delegate. And if the proposal is accepted, it's implemented into the Python code base. So let's go over a historical example. That would be PEP 484, which has to do with type hints. So for anyone that may not be familiar with type hints are a way to essentially make sure that the input and output or a function is of a specific type, for example, integer. So Python is a dynamic language, and functions can accept any type of input or output, and this is definitely a blessing, but in large code bases can be a big hindrance in maintaining clear and readable code. As an example, I have a very simple function here that adds 2 numbers together. So at the top you can see it add 2 numbers without type hints, and at the bottom there's type hints for every input variable, x and y, which would be an integer, and as well as the return value, which is also defined to be an integer. So what this does is it allows an IDE, for example, to catch inconsistencies in the code or early bugs before the final product is shipped, and this allows for much better and better flow in development. Also, a very important part of this proposal is that it's backwards compatible, so it's optional, and it doesn't break all the existing code that exists everywhere that doesn't have type hints, which means that it was able to be accepted and implemented gradually moving forward. So what exactly makes a successful proposal? First of all, and most importantly, it needs to address a clear and distinct problem. That shouldn't happen. Was it Control-Shift? Thank you. Oh, I pressed the wrong one. Okay. Okay, let's continue. So this idea needs to be thoroughly researched, and the champion of the proposal needs to be able to gather any feedback that they receive and put it back into the proposal to improve it. And most importantly for Python, because it's such an open source, project, it needs to have the support of the community. So any proposal that might not have the support of the community, no matter how good it is, in theory, it's probably not going to get implemented. Lastly, other than, of course, the quality of the proposal that is to be good, it has to adhere to Python values. For example, a quote by Tim Peters that I really enjoyed is that beautiful is better than ugly, and simple is better than complex. And this definitely shows when reading Python code that you can always, compared to other languages, at least for me, it's much easier to read and understand it at the first glance. But of course, when it comes to a language people use, a lot of people are gonna have a lot of varying opinions on what is good for a language and what isn't. An example of that caused a lot of controversy would be PEP 572, which is a PEP that introduced the walrus operator. So that walrus operator is this little symbol of the dots with the equal sign. And I guess if you tilt it sideways, it looks like a walrus somehow. The equals would be the teeth. And that's why it's called like that. So what this does is it allows you to assign values to variables in places that normally one couldn't in Python. And this was a very controversial change because a lot of people felt that it was un-Pythonic in nature. It made the code less clear and more confusing. And but a lot of people also thought that this was a very useful tool. It wasn't a tool used often, but when you did, it was very useful to have. So what happened at the end of this proposal is that Guido, who was still the benevolent dictator of all at the time, he decided to accept this proposal. And when he did, the community was erupted in a way. There was a lot of negative feedback towards him. And I think it went to extremes even. So resulting from that, he decided to step down from his position to have and no longer have the final say in all these processes. And that's how the council was created. All right, so I also want to go some other historical PEPs that I found to be very interesting. The first one would be PEP 8, which has to do with coding style. This is a core feature of Python, and it has to do with certain rules or directions to follow when writing Python code. For example, this includes indentation or spacing between and after functions, perhaps how you would name a function, for example, using lowercase letters instead of capitalized, etc. Then there's also PEP 257, which has to do with documentation. So this PEP is the one that introduces docstrings to the language. Docstrings, for anyone who may be unfamiliar, are a way to describe what a function does within that function. So it's essentially a block of text at the beginning of the function that describes what it does. This, for me, is very important, especially for being able to understand what your code does, for example, 6 months or a year after you write it, because that's usually a nightmare for most developers. Then there's PEP 498, which is a favorite of mine. It has to do with the F string. The F string is, I have an example here in the middle that's a bit cut off, but should be still visible. It's being able to add a variable inside a string. So I believe in the past you would have to write a string, then print a variable, and then print the rest of the string. And now you can imbue it inside a string. Then there's PEP 492, which introduces a lot of important asynchronous syntax in Python, such as the async and the await coroutines, which were definitely needed at the time and for Python moving forward. Lastly, I want to go over PEP 8016, which is actually the PEP that, so when Guido stepped down in 2018, the members of the Python community needed to decide how to move forward and who was going to replace him. So what they did is they came up with PEPs. Everyone submitted a lot of proposals. And the one that eventually won was the one that created the steering council. All right, so we went over the historical context of a lot of these proposals and how they helped build essentially the Python that we all use today, or at least most of us probably do. So if anyone wants to participate in this process, it's of course an open community that welcomes everyone to participate. There's a lot of resources that one can use, such as, for example, going through to the Python website and reading through existing proposals that were accepted, or there's also in PEP 1, there's the general guidelines of PEPs that are very interesting to read. And there's a Python developer's guide that I would highly recommend that has a lot of useful tips for Python developers. Also, you can sign up to the Python Ideas mailing list to discuss new and up-and-coming ideas for Python, and participate in the forums where there's a lot of discussion to be had as well. Lastly, there's, of course, you can engage with the local community, such as everyone here today. And if anyone wants to be a core Python developer, there's a mentorship program that helps someone go through that process. Lastly, I wanted to say that every feature that we now have in Python, it wasn't randomly selected or randomly chosen for no reason. Everything has a clear reason that it is the way it is. And it all comes back to an idea that someone had. So I would encourage everyone to, if they have a good idea for Python or anything along those lines, to be brave enough to share that idea, to gain feedback on that, and help build a better Python for the future. Thank you very much.
Thank you very much, Nikos. So do we have any questions for Nikos? No, nothing. You can catch him later on the coffee break.
Thank you.
Thank you very much. So in case any one of you has participated in the Elastic raffle, the announcement of the results will happen at their sponsor desk. Now. And we will be having a 15-minute break for coffee.
Hello, everyone. Thank you for being here. Let's welcome Antonis Kalipetis. He will talk about coroutines and the event loop in Django. Enjoy.
Hello, everyone, and welcome to Athens, or welcome to PyCon, depending on if you're coming from outside of Athens. Let's hope for many more conferences like this one. Yeah, let's see what we're going to talk about today. So a few quick words about me. I'm Antonis. If you want to add me on LinkedIn, feel free to scan this QR code. I'm a software engineer. I'm working currently on a product called Apsan. I'm also a Docker captain, and I love coding in Python, although I don't do it as much in my day-to-day life. I love Django, as you will see in the presentation, so this is my framework of choice. And generally, I love working with teams, either automating stuff, helping with DevOps, local development, and all those things. So enough about me, because that's not very interesting. But what's interesting is what we're going to talk about today. So first of all, we're going to go and talk about some primer, some more basics, and we're going to talk about concurrency and parallelism. And are there people in the room that are clear on the difference between the two concepts? Slight raise of hands. Great, that's a good thing, because we're going to talk about and explain what this is in a bit. Then we're going to talk about the event loop, which is a very important concept when we're talking about concurrency. Why is concurrency? And then we'll go and see some demos and some code so that we can familiarize ourselves on how we're going to use those concepts inside a Django application. So, concurrency versus parallelism. This is a very common misconception among developers. We see many times people either talking about the one or the other and not being really sure about it. So we're going to go slowly with a few examples and see what they are. So let's start with concurrency. So I think this was from Wikipedia. I do not remember where I got this quote, because I've used it in the past as well. So in computer science, concurrency is the ability of different parts of units of a program, algorithm, or problem to be executed out of order or in partial order without affecting the final outcome. So what does that mean? This means that we can split our program with smaller chunks, and we can start executing one or the other in a random order, not very random, but in a kind of random order. And then at the end, we should have a result that is correct. While in parallel, this is a type of computation where many calculations and the execution is happening simultaneously. This means that in every point in time, more than one things are happening. So it's not that we take multiple chunks and then we decide the order of execution, but we take two chunks and we execute them at the same moment. Large problems can be divided in smaller ones that can be easily parallelized, and then this allows us to solve those problems in smaller time. And these concepts might be a bit blurry, but hopefully they will be less blurry as we progress in the presentation. So in order to better understand this, so a quick demo. So this is serial execution. Serial execution means that one thing is happening after the other. So in this example, my hand will be the processor, the CPU, and the ball will be a task. So let's say that I need to work on a task. I can start throwing the ball, catching it again. So my hand, or the CPU, is occupied with the ball at all times. And then if I need to start playing with the next ball, I have to drop the next one, finish what I'm doing, and then continuing throwing the ball. Hopefully the ball will stay near me and will not go towards the audience, but we'll see how this pans out as we progress. Now, when we talk about parallel execution, this means that I have more than one CPUs, and I can keep doing the same work, but I can do it at the same time. So in this case, I have two balls and two CPU cores, one in each hand, and I can keep working at the same time. So as you see, nothing interferes between the two problems. I cannot use the two bolts with one hand, because I need two CPU cores to do the parallel execution. And in this example, you see that we have split the tasks between the two CPU cores, and then I can execute them simultaneously. And I put a lot of emphasis in this word because it really matters. Now, when we talk about concurrent execution, in this example, you see that the same task, for example, task 1 and task 3, does not start and finish and then wait for the others. And maybe you saw in the previous example that my hand, so the CPU, was not occupied at all times with playing with the balls. So this means that, hopefully, if I remember how to juggle, I can use one hand and start, executing those tasks. No, that's... My juggling skills are not as good as my programming skills, hopefully. But the idea is that I can have more than one tasks and then, execute them at the same time, kind of. So I'm occupied with both things, and as one thing is in the air, so it's doing something else, the other task can be in my hand, and I can keep juggling with them. So the idea of concurrency is that when you have tasks that do not necessarily occupy the CPU at all times, to find a way to execute them concurrently, so at the same time. So the question usually that comes to mind is, why not just parallelize stuff? And the answer is not very easy, because it's not easy to parallelize everything, and then you need multiple executors, so multiple hands. I have 2, that's my limit, and maybe your computer has a limited amount of CPU. So parallelizing stuff is not always a possibility. Also, in terms of code, when you parallelize stuff, this means that you need to pose the problem in a way that can be executed, in a way that can be parallelized. But usually the problems that we have are more like serial, so it's not easy to make your code parallel from the get-go. Again, you need multiple CPU cores, again, the hands problem. And the most important thing that I have to share today, and I think it's very important to keep in mind, is that we do not necessarily need to decide to parallelize or make things concurrent, but we have to see how we can make those things happen at the same time. So let's say that we can find applications that do not need to be all the time on the CPU. So in my case, the ball was flying at some point. So those applications are usually web applications, because when your application, let's say, gets hit by a customer or by a user, then you go to the database and ask for a question. What is the ID of user with this session? This is something that dispatches some work to be done by another system, by your database. And in between the time that you started the query and the query result is back, your CPU is staying there idle. So if you start thinking about problems in this way with API calls, database calls, or other things that happen on the background, you start seeing that you oftentimes have applications that do not necessarily need to run all the time on the CPU. So in this case, we can find a way, and we'll see how we're going to do this in a bit, to yield control, to give the control, too many steps. We'll fix it. So to yield control to another process, and it can be executed. So let's say that those balls are requests. While a request comes from your customer, you can serve it, then go to the database when you throw it in the air, and then continue with the other, and so on and so forth. And we can find a way, an executor, that can execute all these micro tasks concurrently at the same time. So an ideal program should all work like this. So in this case, we have 2 CPU cores, so we can do many things in parallel. In a web application, you can think of unicorn workers in this way. So we have multiple unicorn workers that work in this way. And then each worker can do things concurrently. So hopefully this will work, and your program will look like this. So in this way, I will stop here because it worked up to now, and I will not juggle anymore. That was up to what I had to do up to now. And the idea is we can do multiple things in multiple workers at the same time, concurrently. So this is the ideal setup for a web application, and we will start seeing how we can do that thing, that magical thing where we can do many things at the same time in Python. So how can we create or deploy concurrent applications? In Python, there is a concept called coroutines. So anybody in the room familiar with coroutines? So a few of you, that's good. So coroutines are a computer program components that generalize subroutines for non-preemptive multitasking by allowing execution to be suspended and resumed. So this might be too technical, but let's focus on a few of those words. So first of all, the important part is the last one. We can pause and resume those things when we see fit. And when we see fit when we, for example, go to the database. So I start, executing some code, doing some calculations for the customer that just did a request to my service. Then I go to the database. So I say, okay, I'm done here. You can continue working on something else. And when the results are back, I will continue with my application. Or I do an API request, or I do a background task. It's the same concept again and again. It doesn't really matter what I need to do, but when I yield control to something else to be done in the background or in another system, this is where I yield control, so I stop executing, and when the result is back, I will continue with that. And those things are called coroutines. You can find things like green threads or, anyway, many other concepts in other languages. The second thing that we talked about is the executor. We need something that can juggle those balls, those coroutines, in the same way and hopefully better than I did previously. So this thing is called the event loop. The event loop, and again I'm reading from the definition here, is a programming construct or design pattern that waits for and dispatches events for messages in a program. So the idea is that we need somebody or something that when I say, okay, I need to ask something from another API service, yields control to another coroutine, and when the result is back, can give control back to me so that I can continue executing. So this is done with the event loop, which is practically a loop. So it's something that goes through all the active coroutines at all times, and when things are ready for execution, it gives control back to the correct coroutine to keep running. So let's say that we get a bit away from Python and we start with pseudocode to understand how an event loop works. So let's say that we start from step 1. We say that, okay, we have coroutine 0 and we will start executing. So this runs for a few steps. And then at some point, this coroutine needs to go to the network, to the disk, or somewhere where it can yield control. So the event loop will remove this coroutine from the executor, so it will stop executing. It will be, in a pause state, and then it will continue to go into coroutine 1 until it reaches a point where, this coroutine again goes to the database or to the network or completes, and it continues doing this again and again and again and again for all active coroutines at this point. And with coroutines, you can easily map them while not fully correct with actual requests that come from your customers. So when those requests come, they start executing with their first chance. When they hit the network or the database or something else, they stop executing, and then the next one goes again and again. And then at some point, this event loop has finished with all the active coroutines. So let's say that it did 10 coroutines. Now, when it goes to the end, it's going to start checking for results. So it goes and says, okay, did the result from coroutine 0 return? Good, I will continue executing. Did the result from coroutine 1 return? Yes, continue executing. No, go to the next one. And then when you reach the end again with checking all the results, you're going to go back in the beginning and keep looping. So it's a very simple loop. Of course, implementations are more fun and exciting than the one I'm describing, but a very, very simplistic way to describe an event loop is that start running everything. When it yields control, go to the next one, and then start checking all the results and give back control. When you finish with that process, go back to step 1. It's that simple. So it's a loop that goes again and again and again and tries to run all those coroutines and get the results. And of course, again, we're still in the more theoretical land here, and we will start delving more and more into actual Python implementations and how Python actually implements all those concepts that we talked about. So in Python, the most important concept when you want to have asynchronous code is a library called async.io. This library is part of the standard Python library, so you don't have to install something. It's out of the box since Python 3.4. If you try to use it between 3.4 and 3.7, results were not amazing, let's say, because Python was not created as a language with asynchronous concepts at its core. So it was improving and improving and improving. And now, at least in a many of the projects that we have worked and deployed in production, it works amazingly well. But if you give it a try, if you gave it a try between those versions and you're not very happy, give it another try. That's my important suggestion here. The introduction of async IO has some actual language keywords introduced in the Python syntax. The first one is async, which you can prepend before a function. And in this case, you indicate that this function is ready to be run asynchronously. So it might yield at some point, and it will take back control. And the next one is await. Await is a definition that says, OK, do this API, database call, whatever needs to be done there, and I will wait for it, and when the results are back, I will continue running. So await is the way for us to say that this is the time that the event loop can continue to the next coroutine, and when the results from this function execution are back, I will continue running. And of course, apart from those, the async IO library, so you can import it from the system library, has a lot of tools and things to help us do those things. The next thing that we need to implement here is asynchronous web servers, because it doesn't really matter if your code is asynchronous if you run it within a synchronous context, because in this way you cannot, utilize all those nice new things. I did not say this before, but in order to use all this new syntax, you have to use it all the way. You cannot say that, OK, I have a synchronous Python function here and asynchronous here, and the one calls the other, because if you start blocking, then you will block all the other coroutines that are executing at this moment. So it's not that I have too many workers. Usually in a context that we are discussing, I do not have many web workers. I have fewer with more concurrence happening into one of them. So if I block for one, I block for every other coroutine that is stuck with the same worker. So in order to have a synchronous application, I need to go from WSGI, or WSGI, if that was the correct pronunciation, which is the classical interface for creating web applications in Python, to ASGI, or the asynchronous interface of creating such applications. The second thing that I need to do is that I need to start utilizing frameworks that are async ready. So you might have heard of things like, my mind blocked, but there are many asynchronous frameworks in Python, like Ninja, for example, or many others that escape my mind right now. But the good thing about Django is that even though you might have started using it as a synchronous framework, because all the Django core is written as a synchronous framework in Python, you can start blending synchronous and asynchronous things, because Django wants to go and be fully async. It has started adding a lot of nice tools and utilities so that you can start interchangeably using synchronous and asynchronous code. So let's say that you're in Django, you can define an async function with async def, or an async view if you want to be, to have a controller there, and then you can start utilizing those as long as you use an ASGI web server. So this is the important part. Of course, as I told you, Django was written as a fully synchronous framework, so it's not, it doesn't go all the way. It has many things that still need to be implemented to be fully asynchronous. But for example, views are fully sync and async, so you can define one or the other, and you can have even an application that was written previously using synchronous code, and you can start slowly introducing asynchronous functions, and they will work one and the other at the same time. And also it has a variety of decorators, middlewares, and other things that are already async ready. So of course, it's more like a let's see if this works case. So you have to go through your dependencies and the things that you work and see if they are already implemented using asynchronous code. Nothing in life comes for free. Usually things either are expensive or make you a bit more fat. So with Django's case, there are a few caveats that you need to take into account when you start migrating to asynchronous code. So first of all, if you have a lot of back and forth between synchronous and asynchronous code, this means that you have a lot of penalty in terms of time that you get, because it's not very cheap to jump from one context to the other, from asynchronous to synchronous or back. The ORM is not fully asynchronous. You will see some async functions starting with A, the letter A. But even those, they are not fully synchronous if you go very, very deep into the code. So you have some penalty in there, but maybe that penalty is acceptable depending on your case. And especially for middlewares, because they are not all rewritten, you have to make sure that the middleware that you use is compatible already with asynchronous code. So how do you see that? You go to documentation, you check, and then you will see. So where does asynchronous code and using ASCII signs? First of all, static file serving. If you have deployed Django applications in productions, one of the first questions that come to mind is, what the heck do we do with static file serving? How do I serve my JavaScript or CSS files? I have to create a bucket somewhere and serve it from there, or maybe I have a CDN, or maybe I have another implementation. So there's always a question of how. And then if you go fully asynchronous, then this is very cheap, because asynchronous request serving for static assets is very fast and very easy to work with. You get cheap concurrency, so if you have more users, you don't have to deploy more workers of your unicorn server, or more applications one alongside the other, because if your requests are cheap and they only talk to a database or to an external API or do other asynchronous network stuff, you can easily utilize this time and make your applications more efficient without changing anything. You can have better resource usage and allocation, because by making sure that at all times the CPU is occupied, if you remember with the juggling trick, my hands were more occupied when I was juggling more balls than when I was doing one, then you can take more performance out of the same hardware. So that's also a good thing. And as we talked about, Django has a lot of things that help you slowly migrate. So you don't have to, turn a key and then tomorrow your application has to be fully asynchronous. You can start doing this on a case-by-case basis, maybe starting with the views that are more expensive in terms of I/O, network, or database queries. This means that you can do this migration gradually. For example, in a few of our applications, we started deploying them as fully synchronous applications, and then slowly we found the API routes that were more, expensive in terms of network and I/O, and then we start converting those and get, a speed up without doing any significant change there. Of course, nothing is more fun. Maybe juggling is more fun, but demos are always welcome. So for the last few minutes, we're going to see a demo of an application that's a Django application that you can also go to GitHub and check it out, that has these concepts. So let's see what we have here. So here I have a very simple application, which is a single file Django application. I'm using Nano Django, which is a Django wrapper that allows you to create a Django application within a single file. And the only reason I'm doing that is to have everything in one file. It's more like for that case. So here, as you see, I have all my settings here and nothing more important. I have admin, I have conferences and talks. So my application is a way of hosting applications, conferences and talks. And then in the get conferences, I have a call here that sleeps. This is the same as going to a network call and then come back. So I do not do anything fancy here. I'm just adding an artificial delay here. So what I'm going to do is run this application using Ganicorn. Oops. And then I'm going to load test it. So now I'm hitting as much as possible this application, and because I only have, how many? I think 4 Ganicorn workers. Let's see. Oops. Yes, this application could do only 15 requests. So let's do no code changes. So what I'm going to do now is switch to an asynchronous web server. So now I'm using Uvicorn, which is an ASCII server. I did not do any changes to my project. I do the same load test. And in this case, hopefully this will work even better, because all those requests can happen concurrently. So you see, previously I managed to do 15 requests in the same time. Now I did 250. So without changing any code at all, because I'm using Django, I could easily switch to an asynchronous code and then take advantage of all these things. If you open the project, you will see branches that get you through using async IO to improve this further, and then to use even UVcorn with fully asynchronous functions that have some speed up to go to another step. So I think we're almost at time. We have around 5 minutes for Q&A from what I see. So I would like to thank you for being part of this talk. If you would like to get in touch, feel free to get here. Feel free to find me on X, on Agalipetis. If you are Greek, we have a podcast called Mikri Kouveda. And if you are here at 6 p.m., we have an amazing announcement about the conference happening next year around Django. That's all I'm going to say now, but maybe that's a good hint of what's going to happen. So this is it, and if you have any questions, I'm happy to take them.
Any questions?
I think I saw in the unicorn command that you had UVcorn workers. Was it like that, or was it completely different?
So UVcorn is a worker that works with Ganicorn or Unicorn, depending on your pronunciation. So what I did here was initiate Unicorn with UVcorn workers in the second example, so that we can take advantage of all these things. In the first example, we had the synchronous threads.
So it was a pure sync, okay? Because I thought that the first command I saw UVcorn somewhere.
Hopefully not. I will check again, but hopefully not.
Okay, so the make UVcorn was once again Unicorn, but with UVcorn workers. Okay, got it.
So the idea is that you can have asynchronous workers within Unicorn. So you have an already proven process manager for web workers, and then you can use an asynchronous worker to get you to utilize all those things.
Any other questions?
Before this presentation, I didn't know that the async ORM was not completely async.
Yeah, it's a lie.
So do you always have to pay? So do you always pay a penalty when you're doing when you're using the ORM with async interface?
So you pay some penalty, but usually queries are more expensive in terms of time than the penalty that you take. So it makes sense.
Okay.
And I think some of the functions are more async than others. I have not jumped very deep into the code recently, but previously that was the case, at least like a year ago. Maybe recently we have improvements.
And do you know if this depends on the database backend? For example, SQLite or Postgres, if there's any difference in that?
So currently I think all the functions work the same way between backends, and that's why, because we still have backends that are not async ready, that's the reason that we cannot have a fully asynchronous ORM. Some backends that are async ready, I think you can get some more speed up around them. Slowly they migrate to it.
Nice.
Do you have any other questions?
Okay, we are done with the paid questions. Let's go to the actual ones now.
So, like if you are starting a project now, is Django a viable option at this stage? I mean, if you wanted a proper async web framework, Django would not be an option like in the past few years.
So I will answer a slightly different question, which is Python a slow language? That's a very common question that probably all of us get here. And the answer is developer time is still more expensive than actual server time. And the same answer is for Django. So Django, at least for me, you can have different opinions on that, is one of the best frameworks to start with your new application. So I do not see any reason to start coding all the other things that get out of the box with Django just to get a little bit extra speed up on the actual requests. So if you have like a very simple API with a handful of API endpoints and you want as much speed as possible, maybe it's not the best case. But for the 80% case, I think it's still, if not the best, for me it's the best, but if not the best, one of the best options to start a new application. It was a more general answer, but I hope it was close to what you had in mind. Awesome. I think that's it. You lost your chance.
Yeah, the time's up.
Thank you very much.
Thank you. Let's welcome Christos Aridas. He will talk about how can you make your data science workflows reproducible. Enjoy.
Καλησπέρα everyone. I'm Christos Aridas and I work at Satways. At Satways, we build solutions across sectors like civil protection, public safety, critical infrastructure and defense, smart cities, and Industry 4. My role focuses on taking AI from research all the way into production. Today, I will show you how you can bring clarity to our data science workflows by moving into a more structured way of working. So let's start with a familiar situation. First, you are not sure which dataset version went into the analysis. And afterwards, you are staring at the models directory and you are wondering what the final model really is. So these numbers might look good, but without knowing which dataset or model produced them, they can't be trusted. So this is where pipelines really help. In its simplest form, a pipeline, it's a process that takes code, configure data, and produces output or artifacts like models, plots, and metrics. But if you zoom in, a pipeline is a sequence of interdependent steps where the output of a step becomes the input of the next one. So each step is connected, and that structure makes the whole process easier to repeat and reason about. Thank you. So with a structured pipeline, reproducibility tells us that if we run the same experiment again under the same conditions, we should get the same results. So there are several reasons that we should care about reproducibility. Because if we can repeat our work, we can make steady improvements. We need a fair baseline to see if a new idea is really better. We should know how the data turned into a model step by step. Sharing makes it easier to work together and stay clear. And in fields like finance or healthcare, we must show exactly how results were made. Reproducibility can break in many ways, so I will list the common causes and how to control them. At first, differences in systems can give different results. So by using containerization technologies, we can control them and everyone runs in the same setup. Second, libraries and packages change over time. So we can use package managers in order to pin them so we stay consistent. Third, some algorithms have randomness built-in. So setting seeds make the results repeatable. Fourth, even small changes in parameters can change the outcomes. So storing them in config files keeps pipelines and experiments consistent. Fifth, we have the human factor. Manual steps often lead to mistakes. So automating the workflow reduces the errors. And of course, the data itself can change or go missing. Versioning datasets, so experiments can always be produced, is a solution to this problem. And thus brings us to DVC. With DVC, your team can collaborate on data and models the same way you already do with code. You can track every version of datasets and models and roll back at any time. You can run with DVC, compare and organize experiments. Also, DVC provides us an automated pipeline framework ready to use out of the box. It works with Python, with R, or any other stack that you use, and it connects to whatever storage you use. So features are nice, but better see them in action. For today, I have prepared two examples. One example with data versioning and one example with pipeline management experiment tracking. So the first example uses a dataset of okras, bamyes in Greek. People tend to either love them or hate them, but for our use case, it doesn't matter. The dataset is public, so you can try it by yourself. So let's see how the Socrates dataset is organized on disk. I will use a tree command, and as you can see, we have a classic multi-class dataset with one folder for each class. So we start by initializing a Git repository with git init. And if we perform git status, we can see that our project is empty, except from the data directory, which Git doesn't track yet. So then we initialize DVC in the same project, and DVC sets up its own configuration inside this repo. So performing a git status, we can see the configuration file, git ignore, DVC ignore, which is an equivalent for Git for DVC. So now we can commit and start versioning the data the same way we version code. So in order to start track our data directory, we perform a DVC add data. So DVC collects all files in the folder and calculates unique hashes for versioning. Once DVC finishes, it creates a special data.dvc file describing the data. It is a metadata file. So Git can now track this metadata without storing the actual dataset. So the raw data itself is ignored by Git. Instead, Git tracks the new metadata file, and DVC uses the file to track the actual data. So as we can see in the git ignore file, DVC added the data directory, preventing huge file from being committed to our Git repository. So all DVC tracked info, like hashes and file counts, is stored in this special data.dvc metadata file. So Git only sees this small metadata file and not the actual files. DVC keeps the actual data in a cache organized by hash. This makes storage efficient and avoids duplicates. Inside the hash folder that we saw earlier, DVC stores the real files mapped to their relative paths. So that is how it knows which file belongs to which state. Finally, we commit the changes to Git. So the dataset itself stays out of Git, but is fully versioned by DVC. So in order to share or to backup our data, we have to configure a DVC remote where the DVC will send the data. So here it's a local folder for simplicity. So after the command, DVC knows how and where to push and pull the datasets from. Of course, we commit the configuration to Git and perform a DVC push, so the DVC uploads the actual dataset to the remote storage. So after the DVC push executes, all files are now safely stored in the remote, separate from Git repository. So let's now merge the over-mature class into a mature class for simplicity. So now we have just two directories, mature and under mature. So DVC should track the changes automatically. So performing a DVC status shows that the data has changed since last commit. So we commit the updated dataset to DVC, creating a new version that keeping the Git clean. So Git status will show the changes in metadata file data.dvc, like this. So finally, we commit the metadata to Git, but please note that the actual data itself is versioned by DVC and not Git. So now, what if we want to go back to the original dataset? To restore the original dataset, we check the get history to find the commit where it was first added, performing a git log. We find the hash. So we restore the .dvc file from that commit. Please note that this operation updates just the metadata file and not the actual files. Running a DVC checkout updates our workspace to match the restored .dvc file. So DVC fetches the correct version of the dataset from the cache. So now the folder structure is back to the original three classes. performing a git commit, we have now the restored version of the data. So now let's switch to a classic tabular dataset, which is called Titanic. As you can see, our code is modularized into separate modules, where each module performs each stage of a pipeline. So our pipeline is clear and maintainable. We define experiment parameters in a file params.yaml. For example, the test size, the random seed, and a hyperparameters. Here is the neighbors. So this keeps experiments reproducible and easy to tweak. Here we create a DVC stage to split the data. We specify its dependencies, outputs, and parameters, so DVC can track it automatically. All other stages define a similar way, so forming a complete pipeline. DVC generates a dvc.yaml file that lists each pipeline stage, including its commands, dependencies, outputs, and parameters. It's a clear record of the pipeline that can be tracked with Git. With DVC DAG, we can visualize all the stages and their dependencies. And another version of DVC DAG, we can see the output files instead of the dependencies. So this can help us to track artifacts across stages of the pipeline. So we run experiments with DVC exp-run. So DVC automatically determines which stage you need to run based on changes. We will see the pipeline progressively executing all the stages. So like this, 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 and this. DVC exp show displays all experiments, including the master branch and the current workspace. This makes it easy to compare results at a glance without digging through logs. So let's see what happens if we rerun the experiment without change anything. Everything was skipped. This saves time and guarantees reproducibility. But what is really happening? DVC creates a special file to capture the state of the pipeline. The dvc.log file stores exact hashes of all dependencies, outputs, and parameters. This is how DVC ensures that reruns are predictable and fully reproducible. When we run DVC exp-show, we see a new entry for the experiment, even though all its stages were skipped. We can tweak parameters directly from the command line, for instance, changing a hyperparameter like neighbors. DVC only reruns the stages affected by the change, skipping everything else. So this is efficient and ensures the results reflect only the intended modification. For instance, split stage and preprocess stage skipped, while the train stage and evaluate stage run. DVC metrics let us see how metrics change between experiments. So we immediately know if our hyperparameter adjustment improved performance. Now, when we combine DVC with CI/CD, every change in Git can automatically trigger the DVC pipeline. This keeps our workflows up to date, reproducible, and fully tracked without any manual steps. So first, what DVC is. It is a tool for versioning data and models, letting you track them like just you track your code. It's a system for reproducible pipelines and experiment management, letting you keep track of every step and experiment. It's a tool for collaboration and sharing in data science projects, so your team can work together more easily. And what DVC isn't. It is not a replacement for MLflow and weights and biases dashboards. It's also not a database. DVC doesn't replace storage systems for querying or managing huge datasets directly. And finally, DVC isn't a full one-click MLOps platform. It gives you the building blocks for reproducibility and pipeline management, but you still need to integrate with other tools for end-to-end MLOps. So in short, DVC gives you the foundation for reproducible and collaborative data science without pretending to do everything for you. So start your net project right, version your data, track your experiments, and make it reproducible with DVC. Thank you.
Thank you very much. Is there any questions?
Hello, thank you very much. Really interesting tool. I just wanted your view about how can we avoid mingling the data with the code. I feel like the tool gives you the ability, makes data part of your code. Did I get that wrong, or there are ways to avoid that?
Can you please repeat your question, because I didn't understand.
Versioning of your data runs in parallel with Git, so I feel like your Git commits start talking about data and not about the code you are deploying. So how can we make sure that we don't confuse the code development with the data changes over time?
Okay. DVC, as you saw, it's a tool that hashes the contents of the files where you Git ignore them. So DVC generates a metadata file where you can check in it in your repository. So DVC, with a configured remote storage or local storage, knows based on the file which files to call, to fetch from a remote repository or your local cache. So like this, you don't have any data in your repository. You just have a metadata file that instructs DVC where to pull and what to your current directory.
Okay, I understand that. I don't understand how to avoid, when you see your commit history, from my perspective, it should be about code. Bring DVC into the mix. You start referencing about data and how data change. So we're talking both about code development.
Yes, if you change the data, the data.dvc file has changed.
Changed, okay.
So you have a correlation end-to-end between code and data. Actually, you can't see the data because it's in a remote storage. But if you perform DVC pull, you can pull the exact data that your colleague pushed in the remote repository.
Makes sense. Okay.
So you have a complete lineage: data, code, and model, and artifacts, everything.
Nice. Okay.
I forget to say that DVC, when you define your pipeline, everything here is stored in the remote storage, everything. Except if you instruct DVC with another property cache false, where it does not cache this outcome. But if you do it like this and you perform DVC pushes everything to the remote storage. So actually, you don't have to change your code in order to use DVC. It provides an API, so you can get programmatically the parameters, but it's not a requirement. You can call, in the pipeline, you can call executables, whatever executable you want.
Thanks for talk. Stupid question for me. If this tool helps only have a correlation between the versioning of data, right? But if we change the data, we have to keep for example, we change for example, Titanic CSV, right? And we have to keep both files, the new version and old one, in somewhere remotely.
Actually, there are two things. You can even forget the pipeline and go and change your data as you wish, remove lines, add lines, remove lines, add lines, and commit the data itself. But here in the pipeline, DVC keeps the exactly output based on the input. So you don't have to do anything.
Okay, but it's, let's say, commit to get the metadata of the, let's say, state of the file for some data change. For changing.
It's getting done automatically. You don't have to do anything. Just your first file.
Yeah. Maybe you can tell.
Actually, these files are pointers, send links to a local hash. I saw here. Oh, where? Sorry. I didn't say this, sorry. But files are stored here. So the actual files are links, sim links, for instance, to this directory. So DVC has them already. Whatever file is defined in the output is stored here.
Yeah, correct. Okay, correct, but exact data. This is like three versions of data, right?
Yeah.
Of like a hash of
Yeah,
the data.
yeah.
But we have to keep for versioning. Let's say best practice for versioning data. We have to keep all three files. Someone
you don't do it. DVC does it.
Okay.
You don't do it
somewhere where I make the path
to
to
the local cache, which is getting pushed to a remote cache. So a colleague of you can perform DVC pull and pull the
pull the exact data for exact change.
Yeah.
Wow.
So if you run the pipeline, we'll get the same results. Because why? Because where is it? Because the DVC.log. Where is it? Oh, come on. Here. Yeah. Because DVC.log, which is a special file, not human readable, has hashes, and this is the file. So if you try to run the entire pipeline and DVC.log has the hashes locally in your cache, every file that is input or output in the cache, the pipeline won't run.
Okay, understand. Thanks. I would say, wow, amazing. Thank you.
Any other questions? Last chance. Okay, thank you very much.
Πήγες. Είδες. Πω.
Does a whole video of the presentation.
Collaboration. Currently, I work as a software engineer.
I don't know what's going on.
Hello, hi everyone. I am really glad to be here at PyCon Greece today and present my talk. Unfortunately, I couldn't be there in person, but really thankful to the organizers for giving me this opportunity to connect with you all virtually and share my insights. A little introduction about myself. I am Priya Pahava from India, who's trying to navigate the vibrant intersection of all things code, community, and collaboration. Currently, I work as a software engineer at a wealth tech startup. I am the volunteer at the session organizing of Django Space. I'm also a co-chair of the fundraising working group at the TSF. I'm also a GitHub campus expert and a GitHub octern, so most of the time you'd find me wearing a red hoodie, organizing hackathons, workshops, field days, or technical talks. So this was a little something about myself. Before we begin the talk, I just want you to take a moment of reflection. I want you to think about a few things, about few questions to get the best gist out of it. Have you ever been in a meeting, in a chat, and you had a question? A really simple, a really honest question, but you held back from asking it. Maybe you were afraid you'd look inexperienced. Maybe you thought that you'd feel out of place. Or have you ever seen someone treated unfairly? A really small comment that made them feel uncomfortable, even if it wasn't intended that way? Or have you seen a talented person just quietly disappear from a community? No dramatic exit. Just gone, despite you knew that the person actually wanted to volunteer, actually wanted to help. These moments of microaggressions, these moments of unconscious bias, we all are familiar with these in one way or the other. And in the world of open source, where our interactions are often public and permanent, the fear of these moments is amplified even more. Why I'm talking about this? This is because the success of an open source project doesn't solely rely on technical brilliance. It doesn't solely rely on how amazing, optimized the code solution is. It's built on the foundation of culture. Yes, that's what we'll talk about today. Culture eats strategy for breakfast. Why psychological safety matters in open source. In this, we'll explore about why culture is crucial than open source, what is psychological safety, why it matters, what are the practical ways to build a psychologically safe space, how programs like Django Space or Django working groups are working towards onboarding new contributors as well as maintaining the old guard for sustainability. And later we'll figure out how reinforcing this can help us in our daily community practices. Okay, back to the original phrase. Culture eats strategy for breakfast. I'm sure by now you might have your breakfast, lunch, or dinner, so let's not just restrict it towards breakfast, I'd say. It holds true for everything. Okay, jokes aside, it is a phrase that holds a really powerful truth. Just imagine you have the most brilliant roadmap. You have the coolest features and the best plan set for a project. All you have to do is get started. But if people in our community are afraid to speak up, what happens? They hold back their ideas. They don't point out potential flaws. The best part of the plan can never come to life. Strategy is just a set of actions. Culture is what determines if those instructions can be executed or not. All in all, if you focus only on culture, there is no direction. If you focus only on strategy, there is no engagement. These two things must work together, hand in hand, in order to make an open source project thrive. Supporting this, there is a phrase, there is a whole paragraph in the Django's documentation, which I personally feel is a very beautiful metaphor. It states open source is a garden. It is a community tended garden, and we all are gardeners over here. Sometimes we are pulling the weeds, sometimes we are planting the flowers, sometimes we are nurturing growth, but every time the health of this garden depends entirely on how safe we feel as gardeners. In order to ask for a new tool, are we afraid? Are we afraid to admit we made a mistake? In all these things, the garden suffers every time. And the reason I love this metaphor is because it reminds us that it's the job of the community as a whole to manage. The software is never finished, it is always growing. And in order to keep the problems to a minimum, we must choose to nurture what matters. Now, any gardener will tell you that it's not always easy. There are unseen challenges, there are seen challenges. If no one pulls the weeds, they take over. If snails start eating the plants, progress slows down. And if soil isn't rich, plants struggle to grow. But what it means in open source? If issues pile up without clear guidance, new contributors don't even know where to start. If communication slows down, people lose motivation. And if environment isn't welcoming, people just leave quietly, even if they wanted to help. Now, how do we prevent this? According to my belief, the biggest factor in keeping a garden thriving is how safe the gardener themselves feel. This is where the psychological safety and the science behind it comes into practice. Amy Edmondson, who pioneered this concept, notes psychological safety isn't about just being nice, it's about being openly admitting mistakes, it's about giving candid feedback and learning from each other. It is basically a necessity at this point. It is a shared belief that we can take a personal risk, share a new idea, admit an error, ask a naive question without fear of humiliation or retaliation, and realize at the same time that a question was never naive. It is always a curiosity. Google's massive Project Aristotle studied 115 of their engineering teams to figure out what made them effective. They looked at everything: talent, experience, team size, one of the most important factors. Yes, psychological safety. At this point, this concept is just a soft concept. It is measurable. For example, in open source projects, we can analyze some observable cues and keep a track of, let's say, the number of comments on a pull request. More discussion often indicates that people feel comfortable giving as well as receiving feedback, but that also doesn't mean that you just entirely spam the whole GitHub discussion or the comments. Next point, whether a contributor continues to participate even after a pull request is rejected shows that a mistake isn't held against them. They are comfortable in contributing back again with an open mind, with a welcoming environment. The presence of constructive conflict suggests that the team views disagreement as an opportunity for growth rather than just a barrier. In order to make the garden thrive, as we discussed, this is a feeling where it is safe to say, I don't know how to do this. Can someone help me out? I think there is a better way to do this. Let's figure it out all together. It is a group level phenomena. It is the learning behavior of the group that in turn affects team performance. Here, two important terms come into picture: risk taking and vulnerability. These two terms are at odds with what social psychologists call impression management. Especially in the tech space we all are in, there is mostly that instinct that my first PR should create an everlasting impact. It has to be perfect. Or what impression would be there if I fail to debug properly in a code pairing session? What would folks think of me if my PR gets closed even without being merged? What if I review a code in an open source project but my review is not fine? Etc. etc. In one of the works by Professor Brown, she shares, we all use this impression armor to protect ourselves. But that armor is heavy and it prevents us from growing. So having that interdependence within the community is important to cultivate a safe space and break that barrier. A most important question is here now. How do we actually build a safe space? This is where the actionable part comes. There are three key principles which might sound obvious or might sound oddly specific, but they are encouraging curiosity, constructive feedback, and leading by example. Talking about encouraging curiosity, we often state that every expert we know was once a beginner. What we often do not state is a beginner is often terrified to ask question. They don't know if this question is stupid or naive, as said earlier, or whether this is an intelligent question. Actually, the question is just a question. Our job is to make that feeling a superpower instead of a terrific experience. Instead of saying, you should know this, we can say, that's a great question, and rewire the conversation. We must allow experimentation and failure if we want to build up a speak up culture. Next comes constructive feedback over criticism. Feedback is a gift, but it's often delivered in a way that sometimes feels like an attack. A comment like, again, the example we used, this is wrong. It just completely shuts people down. A better way, I see what you were going for. Here's another approach that might help. It's not about being corrective, it's about being collaborative. We must be mindful of perception versus intent when we are dealing with public online discussions. The feedback might have landed wrong or have perceived as a critique, but the intent wasn't always to hurt if it is given by a well-wisher. It just is perceived wrong sometimes because of the cultural differences, because of the psychology that folks have inbuilt. It is not an attack. In most of the cases, it is just a constructive feedback. So, how do we make ensure that it is actually a constructive feedback? We can use the sandwich feedback algorithm. Start with something positive, then give an actionable guidance that you actually want to give to that person, and then end with the positive. It's really simple, but it works. It reinforces progress. it motivates the other person, as well as it gives a clear communication of what you were trying to say. Next up is leading by example. This is on all of us. Culture isn't dictated from top to down, it's demonstrated by every single one of us every single day. When a maintainer or an experienced contributor openly admits they don't know something, it gives everyone else permission to be vulnerable. When we highlight a small contribution, maybe just a typo fix, a little documentation update, we are showing everyone that all work matters. This is about building a culture where we highlight competencies and dismantle perceptions of hierarchy. All in all, no one is expected to have all the answers in this whole universe, right? In fact, mentors themselves learn alongside mentees. This destigmatizes not knowing something, it normalizes admitting gaps in knowledge, and it encourages a culture where asking questions is seen as a strength, not a weakness. If maintainers openly say, I haven't figured this part out yet, let's experiment it together. That together is really beneficial for a beginner in order to make them feel comfortable and psychologically safe in the environment. Another factor is creating Slack threads or GitHub discussions titled Things We Are Still Figuring Out. This encourages a collective learning process. At this point, you might be wondering, does this really make a difference? Does the culture of psychological safety really matters? At this point, yes, the answer is resounding yes. Communities that prioritizes psychological safety retain contributors longer. It attracts diverse talent and creates a welcoming atmosphere. In the world of Django, I have seen this work in action, most notably through Djangonaut Space. If you're wondering what this program is all about, let me brief you about it. It is an 8-week group mentorship program where the folks passionate about Django or the third-party packages start out with the technology, continue working on the technology, looking to deepen their knowledge within the framework, and empowers the contributors with an accessible, inclusive, and structured path. Being a Djangonaut myself in session 1, and now having had the opportunity to be an organizer for session 3 and 4, and also the upcoming session 5, I can say this by my heart that beyond just onboarding contributors, it creates a psychological safe space in action. It fuels long-term sustainability in community. It creates the leadership positions that might potentially come up. The program structure of how this culture is built. There are 3 major roles: Djangonauts, navigators, and captains. Djangonauts are the, again, surprise, surprise, Django passionate contributors who want to contribute to the ecosystem and improve the framework through code or community involvement. Navigators are the technical folks who help the mentees or the Djangonauts with their technical expertise within the framework, while captains focus on community well-being, ensuring a positive experience, and there is the balance between both the aspects. The program goals are to increase sustainability and regular contributions, as discussed, provide an actively accessible and inclusive space. What is this? We'll talk about it. And improve the development and empower everybody in the progress. How do we achieve our goals? We have weekly check-ins where people share their progress and their blockers. This isn't about just being judged. It's about being supported together. Connection is cultivated by recognizing that behind every line of code is a real person, learning, evolving, and striving. This understanding brings a sense of humanity to our work and builds a community on empathy. Yes, connection and accountability. Now, the sponsorship aspect, we organize talks, encourage folks to get involved with Django newsletter. There are grants, there are blog posts, or simply sometimes there is an encouragement with a little nudge that, hey, this topic you are discussing is really insightful. You should submit this as a talk for the upcoming conference. And trust me, this has helped me to learn and grow when I was a Djangonaut. In fact, today as well, I'm learning every day something new in that community. Sometimes there's like, I'm hanging around in the Discord for some open source work, hop in for a co-working session. Such little initiatives help to share the right resources and right leadership within the community. Another value we hold really dear is inclusivity. We don't just make the space and wait, we make the space and invite people in. This active invitation is far more powerful than passive inclusion. And why I am highlighting this? Because when we reach out directly with opportunities that align with their skills and passions, the motivation to contribution follows naturally. Now, where this active and passive inclusion must be put into practice, that depends on the community and who we are targeting. There are some notes from the session organizers orbit that I have listed down in my blog post. I got to learn a lot, honestly, within this program. Why consent matter, when consent matter, because when we are talking about the open source world where discussions are, visible to everybody and dealing in the digitally first space, we must take consent everywhere, follow the code of conduct. So to create that safety, because it starts with us. It isn't always dictated from top to bottom. It's the people who make up the community. It's built through shared responsibilities and shared beliefs. And this is where the balance between autonomy for individuals and teams come into picture, with ensuring collective goals remain clear at the same time. That's how I would like to jump into the role of Django working group, because again, empowering folks as well as focusing on the clear goals. The Django Software Foundation delegates certain powers to working groups, which can then act as a behalf of the DSF without board approvals on very specific items. Some of the working groups include social media. They take care of Django's official profiles and amplify important announcements from the community. There is fundraising working group focusing on the corporate and major donations to keep Django financially sustainable. There is website working group. There is code of conduct working group. All in all, they ensure that it remains a welcoming space to maintain the old guard as well as onboard the new contributors within the ecosystem. If you're interested in helping out, that's great. Each working group has a charter available on the GitHub's Django repository, the SF working group, where you'll find details on how to join. If you have a new idea for a working group, that is even better. The process for proposing is also outlined over there. There are plenty of opportunities in the community. Now, let's talk about how the importance of psychological safety and practical examples can be reinforced in every community beyond just good intentions. There is a concept called recurring cohesion, where groups of developers who have collaborated previously work together again as per deeper trust. The initial step is to break that golden rule, of treat others how you want to be treated. Instead, practice treating others how they want to be treated, because the open source community is huge. People are belonging to different cultures, different backgrounds. So, what frequency of check ins work for them? What communication style makes them feel included? This intentional shift has a great impact on the community culture. No contribution is too small. Yes, the conferences, the sprints, the communities, the celebrations are so vital because these global gatherings reinforce our shared passion and a sense of community. I'm really grateful to the PyCon Greece and the organizers for holding such an amazing conference. The Django 20th birthday celebrations happening all across the globe are an excellent example of this as well. Tools like Django Newsletter intentionally reinforcing our culture is a shout out. A public celebration of wins, a thank you every time we see a first time PR or a documentation fix. We are reinforcing the culture with all these things. We are saying effort of every individual matters. We are celebrating it together. Yet at the same time, we should realize that psychological safety isn't a switch you flip or a policy you enforce. It is the result of a community that actively chooses to support, include, and uplift each other every single day, and it should follow organically. It should take the course naturally rather than forcing it. Sometimes we have to reinforce stuff, but make sure how and where to apply the same. So, what's our job now? The real measure isn't the quality of the code base, right? It's the quality of the culture we cultivate together. The choice that the community as a whole makes every day. The next time we contribute to Django or Python or any open source project, let's ask ourselves this: am I making this space safe for someone else? Am I lifting others up the way I wished I was lifted up? Am I creating a psychologically safe space? Am I focusing on culture or just the strategy? Am I focusing on just the strategy or the culture? This just doesn't happen. It's the choice we make. And when we get it right, we don't just build better software, we build a better, more inclusive future and the sustainability of that software. Thank you so much for listening to me about this talk. I'll be there on Discord. If you have any questions, reach out to me. We'll see you next time. Hope you have an amazing conference. Bye-bye.
Okay, that was Ria. Thank you, Ria. As you said, you can reach out to her for any questions because there won't be a Q&A. So thank you very much.